close your eyes for a moment. Take a deep breath. Now open them again. In that brief darkness, where were you? What happened to your consciousness? It seems like such a simple thing, closing your eyes, opening them again. Yet even this mundane act contains mysteries we've never fully solved. Welcome to a journey through everything we don't know. Not the anxious unknowns that keep you awake at night, but the fascinating, humbling, and strangely comforting mysteries that remind us how much wonder still exists in our universe. Tonight, we're going to explore the boundaries of human knowledge. We'll venture into the questions that have puzzled scientists, philosophers, and thinkers for millennia. We'll discover that admitting we don't know isn't a failure. It's an invitation to marvel at the complexity of existence. So get comfortable. Let the weight of your body settle into wherever you're resting. Let your breathing slow and deepen. And let's begin our exploration of the beautiful unknown.
You are conscious right now. You're aware of reading or hearing these words. You might feel the temperature of the room, hear ambient sounds, or notice thoughts drifting through your mind. But what exactly is consciousness? This is what philosopher David Chalmers called the hard problem of consciousness. Not the easy problems, like how the brain processes information or responds to stimuli, but the fundamental question: why does any of this feel like something? Your brain is made of approximately 86 billion neurons, each connecting to thousands of others, creating a network of unimaginable complexity. Electrical signals zip through these connections at speeds up to 270 miles per hour. Chemical neurotransmitters flood across synaptic gaps. All of this is measurable, observable, physical. But somewhere in that tangle of neurons and chemistry, something remarkable happens. The physical becomes experiential. Wavelengths of light become the redness of red. Air pressure waves become the sound of rain. And somehow, incredibly, all of this creates the feeling of being you. How does matter become experience? How do objective physical processes create subjective felt sensations? We simply don't know. Some scientists propose that consciousness emerges from complexity, that when you put enough interconnected neurons together, awareness naturally arises. Others suggest consciousness might be fundamental to the universe itself, like mass or charge, present even in the smallest particles and merely concentrated in brains. There's integrated information theory, which suggests consciousness exists whenever a system integrates information in a certain way. There's quantum consciousness theories, proposing that quantum effects in brain microtubules might explain awareness. There's panpsychism, the idea that everything has some form of consciousness, however rudimentary. But none of these fully explains the central mystery: why anything feels like anything at all. And here's something even stranger. We can't even agree on what has consciousness and what doesn't.
Right now, you're certain that you're conscious. You have direct, immediate access to your own experience. But how do you know anyone else is conscious? You might say it's obvious. Other people act conscious, they report having experiences, their brains are structured like yours. But couldn't they be philosophical zombies? Beings that act exactly like conscious creatures but have no inner experience at all? How would you tell the difference? This isn't just a philosophical game. This question becomes urgent when we consider animals, artificial intelligence, and even plants. Is your dog conscious? Most people would say yes. Dogs seem to feel pain, pleasure, fear, and joy. But what about a fish? An ant? A bacterium? Where do we draw the line, and why? Recent research has revealed that octopuses, with brains structured completely differently from ours, show remarkable problem-solving abilities and what appears to be playfulness. Plants respond to their environment in sophisticated ways, communicate through chemical signals, and even seem to make decisions about resource allocation. Some researchers argue this constitutes a form of plant consciousness. And what about future artificial intelligence? If we create a computer program that claims to be conscious, that passes every behavioral test we can devise, that insists it has subjective experiences, would it be conscious? How would we know? The philosopher Thomas Nagel wrote a famous paper asking, "What is it like to be a bat?" His point was that even if we know everything about a bat's brain and behavior, we can never truly know what it feels like to experience the world through echolocation, to navigate by sound in darkness, to be a bat. This gap between objective knowledge and subjective experience might be unbridgeable. We might be forever locked in our own consciousness, unable to truly know if others experience reality the same way we do, or even if they experience it at all.
Every night, you lose consciousness. Your awareness fades, and for hours, you're gone. But where do you go? During sleep, your brain remains remarkably active. In fact, during REM sleep, the stage where most vivid dreams occur, your brain is almost as active as when you're awake. Yet your conscious control vanishes. Your rational mind, which carefully monitors reality during waking hours, accepts the impossible. You fly, you meet the dead, you're simultaneously yourself and someone else, and none of it seems strange until you wake. What are dreams? Why do we have them? We don't really know. Some theories suggest dreams are the brain's way of processing memories, sorting through the day's experiences and filing them away. Others propose dreams are random neural firing that your brain tries to make sense of by weaving into narratives. Still others argue dreams serve important emotional functions, allowing us to work through feelings in a safe, simulated environment. But none of these fully explains the phenomenology of dreaming, why dreams feel so real in the moment, why they often contain impossible physics yet seem perfectly logical, why certain themes recur across cultures and individuals. And then there are the stranger phenomena. Lucid dreaming, where you become aware you're dreaming and can sometimes control the dream. Shared dreams, where multiple people report dreaming about the same events. Precognitive dreams, where people dream of events before they happen, which might be coincidence or might be something we don't understand about time and consciousness. There's also the question of what happens to consciousness between dreams, in that deep, dreamless sleep. Are you conscious then? Most people would say no. But how can you be sure? Perhaps you're conscious but simply don't form memories, so it seems like nothing happened. Perhaps consciousness flickers in and out too quickly to notice. Perhaps something else entirely is going on. Sleep remains one of the great mysteries of neuroscience. We know we need it. Deprive someone of sleep long enough, and they'll die. But why? What is sleep doing that's so essential we can't survive without it?
Here's another puzzle. Right now, you're experiencing a unified consciousness. You're aware of multiple things simultaneously. Perhaps the feeling of your body, the sound of this voice, visual information if your eyes are open, thoughts and memories arising unbidden. Yet somehow, all of this comes together into a single, coherent experience. This is called the binding problem. How does the brain, with different regions processing different types of information, create a unified conscious experience? Visual information alone requires different parts of your brain to process color, motion, shape, and spatial location. Yet you don't see these as separate. You see a unified visual field. Add in sounds, touches, smells, tastes, emotions, and thoughts, all being processed in different neural networks, yet all somehow combined into the seamless experience of being you. We don't know how this happens. Some researchers point to neural synchrony, the idea that neurons firing in sync might bind information together. Others suggest consciousness requires a global workspace, where information from different brain regions converges. But these are descriptions more than explanations. They tell us what might happen, but not how subjective unity emerges from objective separation. And here's something even stranger. Sometimes the binding fails. In certain neurological conditions, people lose the ability to bind different features together. Someone might be able to see shapes and colors perfectly well, but can't tell which color belongs to which shape. They might see a red circle and a blue square, but report seeing a blue circle and a red square. The features have come unbound. Other conditions reveal even more profound splits in consciousness. Split brain patients whose corpus callosum connecting their brain hemispheres has been severed sometimes appear to have two separate conscious experiences occurring simultaneously. Each hemisphere can have different preferences, knowledge, and even beliefs unknown to the other. What does this mean for the unity of consciousness? Are we really unified selves? Or are we more like a collection of semi-independent processes that usually manage to act in concert?
This brings us to perhaps the deepest mystery of consciousness, the self. Who are you? It seems like such an obvious question. You're you, the continuous person who has existed throughout your life, who remembers your past and plans for your future, who has a personality and preferences and beliefs. But let's examine this more carefully. The cells in your body are constantly being replaced. Most of your cells are entirely new compared to 7 years ago. Even your neurons, once thought to be permanent, are now known to be replaced in certain brain regions. The physical substance of your body is completely different than it was years ago. Your thoughts and feelings change moment by moment. Your beliefs evolve over time. Your personality shifts over time. Your memories are unreliable, reconstructed each time you recall them, changing subtly with each remembering. Who you are at age 20 and age 80 might share so little in common that they're almost different people. So what makes you, you? What is the continuous thread that connects all these changing moments into a single self? Buddhist philosophy has long argued that the self is an illusion, that what we call I is really just a collection of processes with no underlying essence. Modern neuroscience increasingly agrees. The self appears to be something your brain constructs, a useful fiction that helps you navigate the world but doesn't correspond to any real, unchanging entity. Some researchers propose that the self is a narrative, a story your brain tells about who you are, weaving together memories, sensations, and predictions into a coherent character. This story feels true because your brain is the one telling it to itself, but it's still just a story. Yet, if the self is an illusion, who is it that's being fooled? If there's no one home, who's experiencing this carefully constructed narrative? This question loops back on itself endlessly, creating a strange paradox at the heart of consciousness.
There's one more aspect of consciousness that remains deeply puzzling: the feeling of existing in the present moment. Right now feels special. This moment,
the one you're experiencing as you hear or read these words, has a quality of nowness that distinguishes it from remembered pasts and imagined futures. But what is this nowness? Why does it move? And perhaps most confusingly, what determines which moment is now? According to physics, especially relativity, there's no objective present moment. Different observers moving at different speeds will disagree about what's happening now. The universe doesn't have a cosmic clock ticking away moments in sequence. Past, present, and future all exist equally in the mathematical structure of space-time. Yet, consciousness seems to flow through time, experiencing one moment after another. Your subjective experience has a direction. You remember the past, but not the future. You see causes before effects. You feel yourself moving forward through time. Why? We don't know. Some philosophers argue that the flow of time is an illusion created by consciousness, that all moments exist eternally, but our minds can only access them sequentially. Others suggest consciousness might be fundamental to creating the flow of time, that the universe doesn't move forward until someone observes it doing so. There's also the puzzle of how long now lasts. Is it instantaneous, a knife edge between past and future, or does it have duration? And if so, how much? Experiments suggest our conscious experience integrates information over roughly half a second, meaning what feels like now actually includes events from the recent past. You're always living slightly in the past, in a present your brain has already edited together.
So, consciousness remains mysterious. We don't know what it is, how it arises from matter, whether anything else possesses it, why we lose it in sleep, how it creates unity from diversity, whether the self is real or why time seems to flow. These aren't just gaps in our knowledge that better instruments or cleverer experiments will eventually fill. These might be fundamental limitations on what can be known, perhaps because consciousness is trying to understand itself, like an eye trying to see itself, or a hand trying to grasp itself. Or perhaps, centuries from now, these mysteries will seem quaint. Perhaps future humans or artificial intelligences will look back and marvel at our confusion, the same way we look back at ancient peoples, wondering what stars are made of. But for now, tonight, as you lie here in the dark, consciousness remains the ultimate mystery. The fact that you're experiencing anything at all, that there's something it's like to be you, that the universe has somehow organized itself into patterns that feel and know, this might be the strangest fact about reality. Let that wonder wash over you. You are a mystery to yourself, and that's okay.
Look up at the night sky. On a clear evening away from city lights, you might see a few thousand stars scattered across the darkness. The Milky Way, if you're lucky, might appear as a pale band stretching overhead. It's beautiful, humbling, vast beyond comprehension. But here's something that might surprise you. Everything you can see, every star, every galaxy, every nebula, represents less than 5% of the universe. The other 95% is completely invisible, detectable only through its gravitational effects on the visible matter. We call this missing mass dark matter and dark energy, but these names are more confessions of ignorance than descriptions. We don't know what they are. We just know something must be there. The discovery came gradually. In the 1930s, astronomer Fritz Zwicky noticed that galaxies in clusters were moving too fast. According to the laws of gravity and the amount of visible matter, they should have flown apart long ago. Something invisible was holding them together. Later,
Astronomer Vera Rubin made similar observations of individual galaxies. Stars at the edges of galaxies were moving too quickly. There wasn't enough visible matter to keep them in orbit. They should have been flung into intergalactic space. Yet they remained, racing along at impossible speeds, held by the gravity of something we couldn't see. The most popular theory is that dark matter consists of particles we haven't discovered yet, perhaps weakly interacting massive particles, or WIMPs. Physicists have built extraordinarily sensitive detectors deep underground, shielded from cosmic rays, waiting to catch the rare interaction of a dark matter particle passing through ordinary matter. So far, they've found nothing. The particles, if they exist, are even more elusive than predicted. Alternative theories abound. Maybe dark matter isn't matter at all, but a sign that our understanding of gravity breaks down at galactic scales. Maybe it's primordial black holes left over from the early universe. Maybe it's something even stranger, particles that exist in extra dimensions, barely interacting with our three-dimensional reality. Then there's dark energy, which might be even more mysterious. In 1998, astronomers made a startling discovery. They were measuring distant supernovae to determine how fast the universe was expanding, expecting to find that gravity was slowly putting the brakes on cosmic expansion. Instead, they found the opposite. The universe wasn't just expanding, it was accelerating. Something was pushing everything apart, overcoming gravity on the largest scales.
This mysterious repulsive force was dubbed dark energy, and it makes up about 68% of the universe, more than twice as much as dark matter and visible matter combined. What is it? We have no idea. Some theories suggest it's the energy of empty space itself, the vacuum seething with virtual particles that pop in and out of existence. But when physicists calculate how much energy empty space should have, they get an answer that's wrong by a factor of 10 to the power of 120, a 1 followed by 120 zeros. It's been called the worst prediction in the history of physics. Other theories propose new fields permeating space, or modifications to general relativity, or effects from extra dimensions. Some suggest dark energy might not be constant, but could strengthen or weaken over time, potentially leading to a big rip that tears apart galaxies, stars, planets, and eventually atoms themselves. The truth is, we're like primitive people who can see shadows on a cave wall, but not the objects casting them. We can detect the effects of dark matter and dark energy, but we can't see, touch, or directly observe them. We're trying to understand the universe while being blind to 95% of its contents.
When did the universe begin? How will it end? These questions have occupied human minds since we first looked up at the stars and wondered. Modern cosmology tells us the universe began 13.8 billion years ago in an event called the Big Bang. At that moment, all of space, time, matter, and energy exploded into existence from a singularity, a point of infinite density where the laws of physics break down. But what came before the Big Bang? This question might not even make sense, since time itself began at the Big Bang. Asking what came before time is like asking what's north of the North Pole. The question contains a category error. Yet physicists continue to grapple with it. Some propose the Big Bang wasn't the beginning, but a transition from a previous state, perhaps from a collapsing universe that reached maximum compression and rebounded. Others suggest our universe emerged from quantum fluctuations in a multiverse, or that it's one bubble in an eternally inflating cosmic foam. String theory, which attempts to unify quantum mechanics and gravity, suggests the Big Bang might have been a collision between higher dimensional membranes, brains in string theory terminology. Our universe could be a three-dimensional surface floating in a higher dimensional space,
and the Big Bang was what happened when we collided with another brain. But these are speculations built on incomplete theories. The truth is, we can trace the universe back to fractions of a second after the Big Bang, but that first moment, the actual beginning, remains mysterious. The end of the universe is equally puzzling. Current observations suggest the universe will expand forever, driven by dark energy. Galaxies will drift apart, eventually moving so fast that light from one can never reach another. Each galaxy will become an island universe, alone in the expanding darkness. Within these isolated galaxies, stars will continue to form and die for trillions of years. Eventually, though, all the hydrogen fuel will be used up. The last stars will flicker out. Black holes will remain, slowly evaporating through Hawking radiation over timescales that make the current age of the universe seem like an eye blink, 10 to the power of 100 years or more. When even the black holes have evaporated, the universe will enter what's called heat death, a state of maximum entropy where everything is spread uniformly and no energy differences remain to power any processes. The universe will be dark, cold, empty, and completely dead. This is called the Big Freeze, and it's the most likely fate based on current observations. But there are alternatives. If dark energy strengthens over time, it could lead to the Big Rip, tearing apart galaxies, then solar systems, then planets, then molecules, then atoms, ending in a catastrophic dissolution of matter itself. If dark energy weakens or reverses, gravity might eventually halt expansion and pull everything back together in a big crunch, a mirror image of the Big Bang that could potentially lead to a new Big Bang, starting the cycle over. Some theories suggest the universe might be cyclical, endlessly expanding and contracting, each cycle potentially having different physical laws. Others propose a big bounce, where the universe reaches minimum size and rebounds without ever forming a singularity. And then there are even stranger possibilities. Perhaps the vacuum of space isn't in its lowest energy state. Perhaps we're in a false vacuum that could suddenly decay, releasing enormous energy and rewriting the laws of physics in a bubble that expands at light speed, destroying everything it touches, not in trillions of years, but potentially tomorrow or right now, with no warning possible because the bubble travels at light speed. We don't know which fate awaits the universe. We don't know if time is infinite or finite, if the universe will end or endure, if existence itself is permanent or temporary.
Perhaps our universe isn't alone. This idea has moved from science fiction to serious scientific speculation in recent decades. The concept comes from several different sources. Eternal inflation theory suggests that the Big Bang that created our universe didn't happen everywhere at once. Instead, most of space continues inflating eternally, with pocket universes like ours occasionally bubbling off, each potentially with different physical laws and constants. String theory requires extra dimensions beyond the three of space and one of time we experience. These extra dimensions could be curled up in different configurations, each configuration corresponding to different physical laws. The number of possible configurations is enormous, perhaps 10 to the power of 500, giving rise to a landscape of possible universes. Quantum mechanics might create multiverses. The many worlds interpretation suggests that every quantum event splits reality into multiple branches, each representing a different outcome. Every time a particle could go left or right, the universe branches into two versions, one where it went left, one where it went right. Over time, this creates an incomprehensibly vast number of parallel universes containing every possible history. In some of these universes, you made different choices. In others, historical events unfolded differently. In still others, the laws of physics are different enough that stars, planets, or life never formed at all. But here's the problem. By definition, other universes would be causally disconnected from ours. We can never observe them, visit them, or receive signals from them. They're beyond the reach of any possible experiment. This raises a philosophical question. If something can never be observed even in principle, is it science or metaphysics?
can we meaningfully claim these universes exist if there's no way to detect them? Some philosophers argue that if a theory makes testable predictions about our universe and those predictions prove correct, we should accept the entire theory, even if parts of it involve unobservable entities. If eternal inflation or quantum mechanics or string theory correctly explains what we can observe, we should believe in the multiverse, even though we can't see it. Others insist that science must be empirical. We should only believe in what we can observe or what has observable consequences. By this standard, the multiverse might be interesting speculation, but not science. Personally, I find it humbling to consider that everything we can see, every star and every galaxy in the observable universe, might be just one bubble in an infinite foam, one branch on an ever-splitting tree, one tiny corner of a reality vaster than we can imagine. But we don't know. We might never know. Here's something strange about our universe. It seems remarkably well-suited for life. Change any of several fundamental constants even slightly, and life as we know it couldn't exist. If the strong nuclear force were slightly weaker, atomic nuclei would fly apart and complex atoms couldn't form. If it were slightly stronger, stars would burn out too quickly for life to evolve. The range that allows both stars and complex chemistry is extremely narrow. If the electromagnetic force were different, chemical bonds wouldn't form correctly. Water wouldn't have its unique properties. DNA couldn't exist. If gravity were much stronger, stars would be smaller and shorter-lived, burning out before life could emerge. If it were much weaker, stars wouldn't form at all or wouldn't generate the heavy elements necessary for life. The ratio between the electromagnetic force and gravity needs to be within a certain range for planets to form. The cosmological constant, related to dark energy, must be close to zero, or the universe would have expanded too quickly for galaxies to form, or collapsed back on itself too soon. All these constants and more seem to be fine-tuned to allow for the existence of complexity in life. Change any of them by small amounts, and the universe would be drastically different, mostly just hydrogen gas or black holes, or immediately recollapsing, or racing apart so fast that no structures could ever form. Why is our universe so precisely calibrated? One answer is the anthropic principle. We observe these values because they're necessary for observers to exist. In a universe that couldn't support life, no one would be around to notice. We exist in a universe compatible with our existence, not because the universe was designed for us, but because we could only emerge in a universe with these properties. If there's a multiverse with different physical constants in each universe, then it's not surprising we find ourselves in one of the rare universes that can support life. It's selection bias. We couldn't exist in the others to wonder about them. But this explanation feels unsatisfying to some. It seems to require the existence of countless universes just to explain why ours has the properties it does. Is this parsimony or extravagance? Others argue for design, that the fine-tuning suggests a purposeful creator who set the constants to allow for life. But this raises its own questions. Who designed the designer? And if God can exist without explanation, why can't the universe? A third option is that the constants aren't really free parameters, but are determined by some deeper theory we haven't discovered yet. Perhaps there's only one mathematically consistent set of physical laws, and they happen to be the ones we observe. The apparent fine-tuning would then be illusory. There was never any other possibility. We don't know which explanation is correct. We don't even know if the question is meaningful. Perhaps asking why the universe has the properties it does is like asking why 2 + 2 = 4. It's simply a brute fact about reality that requires no further explanation.
Black holes are among the strangest objects in the universe. They're regions where gravity is so strong that nothing, not even light, can escape once it crosses the event horizon. At the center of each black hole is a singularity, a point of infinite density where the laws of physics break down. Or at least, that's what general relativity predicts. Many physicists suspect that quantum effects might prevent true singularities from forming, but we don't know what actually happens in those extreme conditions. Black holes raise profound questions about the nature of reality. One is the information paradox. According to quantum mechanics, information cannot be destroyed. The total information content of the universe must remain constant. But black holes seem to violate this principle. When something falls into a black hole, all information about it seems to disappear. Whether you throw in an encyclopedia, a computer full of data, or random junk, the black hole ends up with the same properties: mass, charge, and spin. All other information is gone. Stephen Hawking showed that black holes aren't completely black. They emit radiation through quantum effects near the event horizon. This Hawking radiation causes black holes to slowly evaporate. Eventually, a black hole will completely evaporate away. And when it does, where did the information go? Some physicists argue that information is somehow encoded in the Hawking radiation, though we don't know how. Others suggest it might be stored at the event horizon in a two-dimensional holographic form. Still others propose that information might tunnel out of black holes through quantum effects, or that it's destroyed, forcing us to modify quantum mechanics. This might seem like an obscure technical problem, but it strikes at the heart of how the universe works. If black holes destroy information, quantum mechanics is wrong. If information survives, we need to understand how, which might require a complete theory of quantum gravity. Black holes also raise questions about the nature of space and time. Inside the event horizon, space and time switch roles in a sense. You can no more avoid moving toward the singularity than you can avoid moving forward in time. The singularity is in your future, not at a location in space. What does this mean? How can space and time switch roles? What is time, really, if it can transform into space under extreme conditions? And then there's the holographic principle suggested by black hole physics. It proposes that all the information in a three-dimensional region of space can be encoded on its two-dimensional boundary, like a hologram. Some physicists take this further, suggesting our entire universe might be a holographic projection from a lower dimensional boundary. Are we living in a hologram? Is reality fundamentally two-dimensional, with the third dimension being an emergent illusion? It sounds like science fiction, but it's a serious proposal being investigated by theoretical physicists.
At the smallest scales, reality becomes strange in ways that defy intuition. Quantum mechanics tells us that particles exist in superposition, simultaneously in multiple states until observed. An electron can be in multiple places at once. A particle can spin clockwise and counterclockwise at the same time. These aren't possibilities or uncertainty about where the particle really is. The particle genuinely exists in multiple states simultaneously. When you measure a quantum system, it collapses into one definite state. Before measurement, an electron is both here and there. After measurement, it's definitely here or definitely there. But what counts as a measurement? Does it require a conscious observer, or will any interaction do? This question remains contentious. There's also quantum entanglement, which Einstein called spooky action at a distance. When two particles are entangled, measuring one instantly affects the other, no matter how far apart they are. Measure an entangled particle to be spinning clockwise, and its partner immediately becomes counterclockwise, even if it's on the other side of the universe. This doesn't allow faster-than-light communication, because you can't control what result you get from the measurement. But it does mean that entangled particles form a unified system that transcends space. They're connected in a way that seems to violate our intuitions about locality, the idea that things can only be affected by their immediate surroundings. What does this mean? We don't know. The most popular interpretation of quantum mechanics, The Copenhagen interpretation says we shouldn't ask what's really happening before measurement. The wave function, the mathematical description of the quantum state, is all we can know, and asking what lies beneath it is meaningless. Other interpretations disagree. The many worlds interpretation says measurements don't collapse the wave function. Instead, the universe splits into multiple branches, each containing a different outcome. Nothing is really random. Every possibility actually happens in some branch of reality. De Broglie-Bohm theory proposes that particles have definite positions guided by a pilot wave, restoring determinism at the cost of introducing hidden variables and non-locality. Other interpretations invoke consciousness or objective collapse mechanisms or deeper layers of reality we haven't discovered. Which is correct? Amazingly, all these interpretations make identical predictions for any experiment we can perform. They differ only in what they say about the nature of reality itself, questions we can't empirically resolve with current technology, and possibly not ever. So, we don't know what quantum mechanics means. We can use it with incredible precision. It's the most accurately tested theory in the history of science, but we don't understand what it tells us about the nature of reality.
Time has a direction. Eggs break but don't spontaneously unbreak. People age but don't grow younger. You remember the past but not the future. Causes precede effects. Entropy always increases. But why? The fundamental laws of physics, quantum mechanics, relativity, even classical mechanics, are time-symmetric. They work equally well forward or backward in time. If you filmed fundamental particles interacting and played the video backward, it would show equally valid physics. Yet our everyday experience is deeply time-asymmetric. Time has an arrow pointing from past to future, and this arrow aligns across different phenomena. The psychological arrow, we remember the past; the thermodynamic arrow, entropy increases; and the cosmological arrow, the universe expands, all point the same way. Why? The standard answer involves entropy. The second law of thermodynamics says entropy, roughly disorder, always increases in a closed system. A dropped cup shatters into pieces, increasing entropy. The pieces don't spontaneously reassemble because that would decrease entropy. But this just pushes the question back. Why did the universe start with such low entropy? The Big Bang was an incredibly ordered state, all matter and energy compressed into a tiny region. Since then, entropy has been increasing as the universe expands and spreads out. If the universe had started with maximum entropy, it would have stayed that way. No stars, no life, no interesting structures, just uniform chaos. The fact that the universe started with low entropy is what allows the arrow of time to exist. But why did it start that way? We don't know. Some physicists propose that the Big Bang wasn't a beginning, but emerged from a previous state. But then, why did that previous state have low entropy? Others suggest that the arrow of time might be connected to the expansion of the universe, though the exact mechanism is unclear. There's also the puzzle of why we remember the past, but not the future. If the laws of physics are time-symmetric, why does causation seem to flow in one direction? Some argue this is just due to entropy. We can remember the past because memories are low-entropy records, and we can't remember the future because low-entropy states are unlikely to arise spontaneously. But this feels incomplete. Consciousness seems to have an inherent directionality, a flow from one moment to the next. Is this real or illusory? Does time truly flow? Or is that just how consciousness experiences a static four-dimensional universe? These questions connect back to the mysteries of consciousness we discussed earlier. Time, memory, causation and experience are tangled together in ways we don't fully understand.
So the universe remains mysterious. We don't know what most of it is made of. We don't know how or why it began. We don't know how it will end. We don't know if it's alone or part of a multiverse. We don't know why its constants are fine-tuned for life. We don't know what happens inside black holes. We don't know what quantum mechanics means. We don't know why time flows forward. These are not small gaps in an otherwise complete picture. These are fundamental questions about the nature of reality itself. And yet, despite all we don't know, we've learned so much. We've measured the age of the universe to within tens of millions of years out of 13.8 billion. We've detected gravitational waves from colliding black holes a billion light years away. We found thousands of planets orbiting other stars. We've traced cosmic evolution from the first moments after the Big Bang to the present day. Science is a conversation between what we know and what we don't. Each answer raises new questions. Each solved mystery reveals deeper mysteries beneath. And that's beautiful. If we knew everything, if all questions were answered, if no mysteries remained, that would be the end of wonder. The universe would become mundane, fully mapped, completely understood. Instead, we live in a universe that perpetually surprises us, that always has one more secret to reveal, one more layer to peel back. Let yourself feel small for a moment, not in a diminishing way, but in a way that connects you to something vast and ancient. You are made of atoms forged in the hearts of dying stars. You are the universe become conscious, matter arranged in such a way that it can contemplate itself. And there's so much more to contemplate.
How did life begin? This is one of the most profound questions we can ask, and despite decades of research, we still don't have a complete answer. We know life on Earth emerged relatively quickly, at least in geological terms. The Earth formed about 4.5 billion years ago. The earliest evidence of life dates to 3.7 billion years ago, possibly even earlier. That's a window of less than 1 billion years. Quick, considering how complex even the simplest living cell is. A living cell is almost incomprehensibly sophisticated. It has a membrane that separates inside from outside while allowing specific molecules to pass through. It has metabolism, chemical reactions that extract energy from the environment. It has information storage in DNA or RNA, with mechanisms to read and copy that information. It has ribosomes that build proteins according to genetic instructions. It has repair mechanisms, waste disposal, and regulation of countless internal processes. All of this had to somehow emerge from non-living chemistry. How? The classic experiments by Stanley Miller and Harold Urey in the 1950s showed that amino acids, the building blocks of proteins, could form spontaneously from simple chemicals and energy sources like lightning. This was encouraging, but amino acids are a long way from a living cell. One major puzzle is the chicken and egg problem of DNA and proteins. DNA stores genetic information, but you need proteins to read and copy DNA. Proteins do the work of the cell, but you need DNA to specify how to build proteins. Which came first? The leading answer is RNA. RNA can both store information like DNA and catalyze reactions like proteins. This has led to the RNA world hypothesis, that early life used RNA for both information storage and metabolism, with DNA and proteins evolving later. But even this pushes the question back. How did self-replicating RNA molecules first form? RNA is complex.
Getting the right building blocks to link up in the right order by chance seems impossibly unlikely. Some researchers focus on simpler self-replicating molecules that might have preceded RNA. Others investigate how mineral surfaces might have catalyzed the formation of complex organic molecules. Still others explore how lipid membranes, the basis of cell membranes, might have spontaneously formed compartments that concentrated molecules and created favorable conditions for life to emerge. There's also the question of where life began. On Earth's surface, in a warm little pond, as Darwin speculated, in hydrothermal vents deep in the ocean, in clay deposits, in ice, on Mars with life then being transported to Earth on meteorites. Each scenario has its proponents and problems. We don't know which, if any, is correct. And then there's the possibility that life didn't emerge gradually, but suddenly in what's called a phase transition. Just as water suddenly freezes into ice when it reaches a critical temperature, perhaps non-living chemistry suddenly becomes living when certain conditions are met. But what those conditions are and what the transition looks like remains mysterious.
For billions of years after life emerged, it remained simple. Single-celled organisms, bacteria and archaea floating in the oceans. Then about 2 billion years ago, more complex cells with nuclei emerged. These eukaryotes were still single-celled, but they were larger and more sophisticated. For another billion years, life remained microscopic. Then, around 600 million years ago, the first multicellular animals appeared. Simple, soft-bodied creatures that left few fossils. And then, about 541 million years ago, something extraordinary happened. In a geological eye blink of perhaps 20 million years, which is fast when you're dealing with billions of years of history, most of the major animal body plans appeared. This is the Cambrian explosion. Suddenly, the fossil record is full of diverse, complex animals. Arthropods with jointed legs and compound eyes. Chordates, the ancestors of all vertebrates, including us. Mollusks, worms of various kinds, bizarre creatures like Anomalocaris, a meter-long predator with grasping appendages and circular jaws. What caused this sudden burst of diversity? We don't really know. One theory is that oxygen levels in the atmosphere reached a critical threshold, allowing larger, more active animals to evolve. Another is that the evolution of predation drove an evolutionary arms race. Once animals started eating others, there was strong selective pressure to develop defenses, shells, spines, speed, and better hunting abilities, eyes, mobility, and jaws. The evolution of eyes might have been particularly important. Before eyes, animals sensed their environment through chemical signals and touch. With eyes, they could detect prey or predators from a distance, enabling new hunting and defense strategies. There's also the idea that the evolution of Hox genes, master control genes that determine body plan during development, allowed for rapid experimentation with different body forms. Or perhaps it was environmental changes, the breakup of a supercontinent, creating new habitats, or climate changes, or changes in ocean chemistry. Most likely, it was a combination of factors, but the rapidity and scope of the Cambrian explosion remains somewhat puzzling. Why did it take so long for complex animal life to appear? And then, why did it diversify so quickly once it did?
Speaking of oxygen, there's an earlier mystery in life's history that's equally profound. How did oxygen come to dominate Earth's atmosphere? The early Earth had almost no free oxygen. Oxygen is reactive. It tends to combine with other elements rather than floating free. The ancient atmosphere was mostly nitrogen, carbon dioxide, methane, and other gases. Then, around 2.4 billion years ago, oxygen levels suddenly spiked. This is called the Great Oxygenation Event, and it transformed the planet. The oxygen came from cyanobacteria,
photosynthetic organisms that split water molecules, use the hydrogen in their metabolism, and release oxygen as waste. These bacteria had probably been around for a while, but initially, all the oxygen they produced was consumed by chemical reactions with iron dissolved in the ocean and other reduced compounds. Eventually, though, these oxygen sinks became saturated. Oxygen began accumulating in the atmosphere. This was catastrophic for most existing life. Oxygen was toxic to the anaerobic organisms that dominated early Earth. It may have caused the first mass extinction, but it also opened up new possibilities. Oxygen-based metabolism is much more efficient than anaerobic metabolism. It provides far more energy, enabling more complex and active life forms. Without the Great Oxygenation Event, complex life as we know it probably couldn't exist. Yet, we still don't fully understand the timing. Why did oxygenation happen when it did? What triggered the transition from an anoxic to an oxic world? Was it purely biological, cyanobacteria finally outpacing oxygen sinks? Or were there geological or astronomical factors involved? Some researchers point to changes in volcanic activity or continental erosion that altered the balance. Others suggest changes in bacterial ecosystems or evolution of new metabolic pathways. We're still piecing together the full story.
We've discussed the mystery of consciousness in humans, but what about other animals? Where does consciousness begin? Who else experiences the world? Your dog almost certainly has some form of consciousness. Dogs show clear signs of emotions: fear, joy, affection, anxiety. They solve problems, make decisions, and have distinct personalities. Few people would doubt that there's something it's like to be a dog. But what about a mouse, a lizard, a frog, a fish? Fish, long considered simple and unfeeling, have surprised researchers in recent years. They use tools, they recognize individual humans, they show signs of pain and distress. Some species appear to mourn their dead. There's growing consensus that fish, like mammals, are sentient beings with subjective experiences. But what about insects? A bee's brain contains less than 1 million neurons, tiny compared to our 86 billion. Yet bees learn, remember, communicate through dance, and can even count. Are they conscious? Some philosophers argue that consciousness requires a certain level of complexity, and insects fall below that threshold. Others point out that consciousness might not require human-like brains. It could be implemented in very different ways. Octopuses are particularly intriguing. They're mollusks, more closely related to clams than to us, and their brains evolved completely independently from vertebrate brains. Yet they show remarkable intelligence, solving puzzles, using tools, learning by observation, even displaying playfulness and curiosity. An octopus has a distributed nervous system. About 2/3 of its neurons are in its arms rather than in its brain. Each arm can act semi-independently, almost like it has its own mind. What would consciousness feel like with such a distributed architecture? Do octopuses have a unified sense of self, or something more alien? And then there are even stranger cases. Plants respond to their environment in sophisticated ways. They communicate chemically with other plants, warning of insect attacks. They make decisions about resource allocation. Some can even learn in a sense, changing their responses based on past experiences. Does this constitute consciousness? Most researchers say no. Plants lack nervous systems and anything resembling a brain. Their responses are chemical and mechanical, not experiential. But how can we be sure? What objective test could distinguish between unconscious responsiveness and conscious experience? Some philosophers argue for panpsychism, the idea that consciousness is a fundamental feature of matter, present even in simple systems, and merely more concentrated and integrated in brains. By this view, everything from electrons to plants to humans has some form of consciousness, differing in degree but not in kind. Others insist consciousness requires specific neural architectures found only in animals with sufficiently complex brains. By this view, consciousness is rare and precious, limited to a small subset of living beings. We don't know. We might never know. The private nature of consciousness means we can't directly observe it in others. We can only infer it from behavior and brain structure, and these inferences are always uncertain.
Humans have 5 traditional senses: sight, hearing, touch, taste, and smell. But many animals have senses we lack entirely, ways of perceiving the world that we can barely imagine. Many birds can see ultraviolet light. Flowers that look plain to us are covered in UV patterns that guide pollinators. Urine trails, invisible to us, glow in UV, allowing predators to track prey. Birds likely see a world richer and more colorful than we can conceive. Snakes have infrared vision. Pit vipers have organs that detect heat, allowing them to see the warm bodies of prey in complete darkness. What does the world look like in infrared? How do snakes integrate these heat images with their regular vision? Many fish can sense electric fields. Some, like electric eels, generate their own electric fields and sense distortions in them, allowing them to navigate and hunt in murky water. Others detect the weak electric fields generated by muscle contractions in other animals. They live in a world of electric perception we can't directly access. Sharks can detect magnetic fields, possibly using them to navigate across oceans. Sea turtles do the same, somehow imprinting the magnetic signature of their birth beach and returning to it decades later to lay eggs. Many insects see polarized light waves vibrating in specific orientations. They use patterns of polarization in the sky for navigation, finding their way even when the sun is hidden by clouds. Bats and dolphins echolocate, emitting sounds and listening to the echoes to build a sonic map of their environment. They can detect objects smaller than a millimeter and distinguish between different materials based on how they reflect sound. Imagine seeing with sound, perceiving shape and texture through echoes. What are these experiences like? How does it feel to sense magnetic fields, to see in infrared, to echolocate? We can describe the physics and the neural processing, but we can't know the subjective quality of these experiences. Thomas Nagel's question, "What is it like to be a bat?" applies to all these cases. We can never truly know what it's like to have senses different from our own. Each species might inhabit its own sensory world, its own reality shaped by its unique perceptual abilities. This raises a humbling thought. Our human experience of reality is just one possible experience among countless others. The world we perceive, colors, sounds, textures, is not reality itself, but our species-specific interface with reality. Other animals perceive different aspects, construct different worlds. What is reality really like, independent of any observer's perceptions? We don't know. Perhaps the question doesn't even make sense.
Life on Earth has nearly ended multiple times. There have been 5 major mass extinctions in the past 500 million years, each wiping out the majority of species. The most famous is the extinction of the dinosaurs 66 million years ago. An asteroid 6 miles wide slammed into the Yucatan Peninsula, releasing energy equivalent to billions of nuclear bombs. The impact threw up a dust cloud that blocked the sun for years, causing temperatures to plummet. Acid rain fell. Wildfires raged across continents. 3/4 of all species went extinct,
including all non-avian dinosaurs. Mammals, which had been small and mostly nocturnal, suddenly had ecological niches to fill. They diversified rapidly, eventually giving rise to primates, and ultimately to us. But even this wasn't the worst extinction. That distinction belongs to the Permian-Triassic extinction 252 million years ago, often called the Great Dying. Over 90% of marine species and 70% of terrestrial species went extinct. Life came closer to ending completely than at any other time we know of. What caused it? The leading theory involves massive volcanic eruptions in Siberia that lasted for about 1 million years. These eruptions released enormous amounts of carbon dioxide and methane, causing runaway greenhouse warming. Ocean temperatures rose, circulation patterns broke down, and the oceans became anoxic, depleted of oxygen. Hydrogen sulfide, a toxic gas, accumulated in the deep ocean and eventually escaped into the atmosphere. The result was a planet-wide catastrophe that lasted for millions of years. Recovery was slow. It took nearly 10 million years for ecosystems to fully recover and for biodiversity to return to pre-extinction levels. The other major extinctions had various causes: ice ages, sea level changes, more volcanic eruptions, possibly asteroid impacts. In each case, the exact sequence of events and the relative importance of different factors remain debated. And now, we're possibly in the midst of a 6th mass extinction, this time caused by us. Species are going extinct at rates comparable to the previous mass extinctions due to habitat destruction, climate change, pollution, and overhunting. This raises uncomfortable questions. Are we witnessing the end of an era? Will future geologists see a distinct layer in the rock record marking the Anthropocene, the age of humans, characterized by a dramatic loss of biodiversity? And if so, what comes after? Will life recover and diversify again as it has after previous extinctions? Will something new and unexpected evolve to fill empty niches? Or have we altered the planet so fundamentally that recovery is impossible?
If life emerged on Earth, and if consciousness and intelligence evolved here, why wouldn't the same thing happen elsewhere? The universe contains hundreds of billions of galaxies, each with hundreds of billions of stars. Many of those stars have planets. Many of those planets should be in the habitable zone where liquid water can exist. With such enormous numbers, it seems almost certain that life should have emerged elsewhere. And if life emerged, intelligence and technology could evolve. And if technology evolved on a planet even slightly older than Earth, that civilization could be millions or billions of years more advanced than us. Such a civilization should be visible. They might build megastructures that alter the light from their star. They might send out self-replicating probes that spread across the galaxy. They might communicate using powerful transmitters we could detect. Yet we see nothing. We hear nothing. The universe appears silent and empty. This is the Fermi Paradox, named after physicist Enrico Fermi, who supposedly asked, "Where is everybody?" Many solutions have been proposed. Maybe life is much rarer than we think. Perhaps the origin of life, or the evolution of complexity, or the emergence of intelligence requires such an unlikely chain of events that Earth is unique, or nearly so. Maybe intelligent civilizations destroy themselves before becoming spacefaring. Perhaps technological development inevitably leads to nuclear war, environmental collapse, or creation of dangerous AI. We might be doomed to repeat this pattern. Maybe advanced civilizations deliberately hide. Perhaps they observe younger civilizations without making contact, waiting to see if we mature enough to join some galactic community. or perhaps revealing themselves to primitive civilizations is considered unethical or dangerous. Maybe we're looking in the wrong ways. Perhaps advanced civilizations don't use radio signals. They communicate in ways we haven't imagined. Or perhaps they transcend physical reality entirely, uploading their consciousness into virtual worlds or evolving into something beyond our comprehension. Maybe space travel is harder than science fiction suggests. Perhaps the distances are simply too vast, the speeds too slow, the resources required too enormous for any civilization to spread across the galaxy. Or maybe we're early. Perhaps life emerged on Earth relatively early in the universe's history, and we're among the first civilizations to arise. In a few billion years, the galaxy might be teeming with life, but right now, we're alone. Each solution is unsettling in its own way. Either we're fantastically unlikely, facing inevitable doom, being watched by hidden observers, missing something fundamental, trapped by physics, or alone in a vast and ancient universe. We don't know which, if any, is correct. We search the skies and listen for signals, but so far, we've found only silence.
You're understanding these words right now. Somehow, these patterns of sound or symbols trigger thoughts and images in your mind. This capacity for language is one of the most distinctive features of human beings. Yet, its origins remain mysterious. All human societies have language. Complex, grammatical language, capable of expressing abstract concepts, past and future events, and things that don't exist. Even isolated communities that have had no contact with others for thousands of years have fully developed languages as complex as any other. This universality suggests language is deeply rooted in human biology. Children acquire language easily and naturally, passing through similar developmental stages regardless of which language they're learning. There appears to be a critical period. If children aren't exposed to language before roughly age 12, they can never fully acquire it. This has led linguists like Noam Chomsky to propose that humans have an innate language faculty, a biological capacity for grammar hardwired into our brains. According to this view, all human languages share a universal grammar, deep structural similarities that reflect this innate capacity. But where did this capacity come from? How did language evolve? Some researchers propose that language evolved gradually from animal communication systems. Primates have calls that communicate simple messages, alarm calls for predators, food calls, contact calls. Perhaps human language emerged through gradual elaboration of such systems. Others argue that language required sudden mutations that reorganized the brain, creating entirely new capacities not present in our ancestors. Perhaps a single genetic change 100,000 years ago gave humans grammar, allowing for unlimited combination and recursion, the ability to embed phrases within phrases to create infinite meanings from finite elements. The archaeological record provides tantalizing clues, but no clear answers. Anatomically modern humans appeared about 300,000 years ago, but when did they start using language? Art and complex tools appear in the record around 100,000 years ago, suggesting symbolic thought, but language might have preceded or followed this. Other researchers look at the physical requirements for speech. The human vocal tract is uniquely suited for producing a wide range of sounds, but this anatomy evolved over millions of years. Did language drive these changes or enable them? Others focus on the brain. Humans have enlarged Broca's and Wernicke's areas involved in language production and comprehension. We have stronger connections between auditory and motor regions. But when did these changes occur? And then there's the question of what selective advantage language provided. Why would our ancestors who could speak outcompete those who couldn't? Some suggest language improved cooperation.
allowing for better hunting and gathering. Others emphasize teaching. Language allows knowledge to be passed down generations. Still others propose social bonding or even courtship display. The truth is, we don't know exactly when, how, or why language evolved. We don't even fully understand how the brain produces and comprehends language today. We know certain regions are involved, but the exact mechanisms by which neural activity becomes meaning remain mysterious.
Why are some people geniuses? What makes someone capable of insights that elude everyone else? Consider mathematics. Most people struggle with advanced mathematics, but a small number of individuals seem to perceive mathematical structures directly, almost intuitively. Srinivasa Ramanujan, a self-taught Indian mathematician, produced thousands of novel theorems, many of which took decades to prove. When asked how he discovered them, he said they came to him in dreams, revealed by a goddess. Or consider music. Mozart composed his first symphony at age 8 and produced masterpieces throughout his life with seemingly effortless fluency. He reported that entire compositions would appear in his mind fully formed, and he merely had to write them down. Is genius genetic? Environmental? Both? Neither? Studies of genius are complicated by the rarity of the phenomenon and the difficulty of defining it. High IQ correlates with achievement, but doesn't guarantee genius. Plenty of people with exceptional intelligence lead ordinary lives, while some with more modest scores make revolutionary contributions. Personality traits matter. Conscientiousness, openness to experience, and willingness to work obsessively on problems correlate with creative achievement, but these traits are common among successful people who aren't geniuses. Practice matters. The 10,000-hour rule suggests that expertise requires extensive, deliberate practice. But this explains competence, not genius. Plenty of people practice intensively without achieving revolutionary insights. Some researchers focus on brain differences. Einstein's brain showed unusual features, including a larger parietal lobe and different patterns of connectivity. But we don't know if these differences caused his genius or resulted from his intensive mathematical thinking. There's also the role of historical timing. Genius often involves connecting ideas in new ways, and this requires the right ideas to already exist. Newton couldn't have developed calculus without the mathematical foundations laid by his predecessors. Darwin couldn't have proposed evolution without access to geological evidence and observations from global exploration. So genius seems to require multiple factors: innate ability, personality traits, intensive effort, and historical opportunity. But this still doesn't explain why some individuals make connections others miss. What allowed Einstein to see that space and time could curve? What let Darwin recognize evolution when others looked at the same evidence and saw only confusion? We don't know. Genius remains mysterious, perhaps because it represents the extreme tale of human cognitive variation, or perhaps because it involves cognitive processes that even geniuses themselves can't articulate.
Give someone a sugar pill and tell them it's medicine, and often they'll get better. This is the placebo effect, and it's more powerful and stranger than most people realize. Placebos can reduce pain, improve depression, lessen Parkinson's symptoms, boost immune function, and affect a wide range of conditions. The effects aren't just subjective. Placebos can cause measurable physiological changes. In pain studies, placebos activate the brain's natural pain-killing systems, releasing endorphins and other neurotransmitters. Brain imaging shows that taking a placebo actually changes pain processing in the brain. It's not just that people say they feel less pain, their brains genuinely register less pain. In Parkinson's disease, placebos can cause the release of dopamine in the brain, temporarily alleviating symptoms. In depression, placebos can be nearly as effective as antidepressant medications, at least for mild to moderate cases. Even more strangely, the effectiveness of placebos depends on context. Larger pills work better than smaller pills. Expensive placebos work better than cheap ones. Branded placebos work better than generic ones. Injections work better than pills. Surgery creates stronger placebo effects than less invasive procedures. The color matters too. In Western countries, blue pills are better sedatives while red or orange pills are better stimulants, matching cultural associations with calming water, sky, and stimulating fire. Different cultures show different color effects. And the placebo effect works even when people know they're taking a placebo. Studies of open-label placebos show that honestly telling people they're receiving an inactive treatment can still produce significant benefits. Somehow, knowing you're taking a sugar pill doesn't completely eliminate the effect. How does this work? The current understanding involves expectation and conditioning. If you expect a treatment to help, your brain activates healing mechanisms. If you've been conditioned by past experiences with medicine, your brain responds to the ritual of treatment. But this just describes the effect, not explains it. How does expectation activate endorphin release? How does belief influence immune function? By what mechanisms do thoughts and expectations change physiology? These questions connect to deeper mysteries about the relationship between mind and body. We tend to think of them as separate. The mind is conscious experience, the body is physical machinery. But the placebo effect shows this separation isn't absolute. Mental states directly influence physical health. This opens uncomfortable questions for medicine. If belief and expectation are powerful healing mechanisms, should doctors intentionally cultivate them? Should they exaggerate treatment benefits, underplay side effects? Where's the line between therapeutic optimism and deception? And it raises questions about the nature of illness and healing. If your mind can make you better, can it also make you sick? The nocebo effect, where negative expectations cause harm, suggests yes. Tell people a harmless substance might cause headaches, and many will develop headaches. Show someone fake scientific evidence that Wi-Fi causes symptoms, and they will report symptoms when exposed to Wi-Fi, even fake Wi-Fi that's actually off. The boundary between physical and mental illness becomes blurry. Is depression a chemical imbalance, or does negative thinking create the chemical imbalance? Is chronic pain a nerve problem, or does focus on pain amplify neural signals? Probably both, in complex feedback loops we don't fully understand.
Your memories feel real, definite, accurate. But memory is far more unreliable and malleable than most people realize. Every time you recall a memory, you reconstruct it. You don't retrieve a fixed recording like playing a video file. Instead, you reassemble the memory from fragments, filling in gaps with assumptions and inferences. And each time you do this, the memory can change. Psychologist Elizabeth Loftus has demonstrated how easy it is to implant false memories. Show people manipulated photos of themselves at childhood events they never attended, and many will remember those events, adding details and emotions. Ask leading questions about witnessed events, and people will incorporate the suggestions into their memories. In one famous experiment, researchers convinced about 25% of participants that they had been lost in a shopping mall as children, an event that never happened. The participants didn't just accept the false story, they elaborated on it, adding sensory details and emotional reactions. Even more disturbing, these false memories feel identical to real ones. People who've been convinced they experienced events that never happened are often certain of their memories, even when confronted with evidence they're false. This has serious implications for eyewitness testimony, which juries tend to find highly convincing. Yet research shows eyewitnesses are often wrong, especially when identifying perpetrators or recalling details of fast-moving events. Memory doesn't work like a camera. It's more like a Wikipedia article that anyone can edit, including the author.
but it goes deeper. Not only are specific memories unreliable, but our understanding of our own past is often inaccurate. We remember ourselves as more consistent than we were. If we currently hold a belief, we tend to remember always holding it, even if we actually changed our mind. We edit our past to match our present. If a relationship ends badly, we rewrite the history to have been worse than we thought at the time. If we've changed politically, we remember being less extreme in our previous views. This isn't deliberate lying, it's automatic reconstruction. Your brain is constantly revising your personal narrative to maintain coherence and self-consistency. The person you remember being might be partly fictional. And here's the deepest mystery. If your memories are unreliable, if your past is constantly being rewritten, then who are you? If personal identity depends on continuity of memory, but memory is neither continuous nor accurate, then who are you?
Have you ever had the uncanny feeling that you've experienced the current moment before? That's déjà vu, and while common, about 2/3 of people have experienced it, it remains poorly understood. The leading theory is that déjà vu results from a brief neural glitch where information reaches consciousness through two pathways at slightly different times. Your brain registers the same scene twice in quick succession, creating the false feeling of repetition. But this doesn't explain all features of déjà vu. Often, it's accompanied by a feeling that you'd not only experienced this before, but that you know what will happen next, yet you can't quite articulate what that is. There's a sense of prophetic knowledge that remains frustratingly out of reach. Some researchers propose déjà vu relates to memory processes. Perhaps a current scene partially matches a forgotten memory, creating a sense of familiarity without explicit recollection. Or perhaps it's a mismatch between familiarity and recall. Your brain signals that something is familiar, but can't retrieve the relevant memory. Then there are rarer, stranger experiences. Jamais vu, the opposite of déjà vu, where familiar things suddenly feel unfamiliar. You look at a common word and it seems alien. You're in your own home, but it feels like a stranger's house. There's also the phenomenon of false awakening, where you dream that you've woken up, sometimes repeatedly. You dream you're getting out of bed, getting dressed, starting your day, then actually wake up and realize it was all a dream. Some people report false awakenings nested several layers deep. Sleep paralysis affects many people. You wake up but can't move. Often this is accompanied by a feeling of presence, someone or something in the room with you, sometimes visual or auditory hallucinations. The experience can be terrifying, though it's a natural, if unusual, part of the sleep-wake transition. Some people experience synesthesia, as we discussed earlier, senses crossing so that sounds have colors or numbers have personalities. Others have prosopagnosia, face blindness, unable to recognize faces, sometimes even their own. There are people who can't visualize anything in their mind's eye, a condition called aphantasia, and people who visualize so vividly that mental images are nearly as clear as perception, hyperphantasia. All these variations reveal something profound. Consciousness isn't one thing, but a collection of processes that usually work in concert but can come apart. Our unified sense of self and reality is constructed from many components, and when those components malfunction or disconnect, we get glimpses of how strange consciousness really is.
Do you have free will? Did you choose to listen to or read this, or was that choice determined by prior causes? Your brain state, your environment, your genetics, your history? This question has been debated for millennia, but neuroscience has added new dimensions to it. Studies show that brain activity predictive of a decision
can be detected several seconds before someone becomes consciously aware of making the decision. In these experiments, participants decide to press a button with either their left or right hand whenever they feel like it. They report the moment they made the decision, but brain scanners can predict which hand they'll choose up to 10 seconds before the conscious decision. Does this mean free will is an illusion? That decisions are made unconsciously and consciousness just witnesses them after the fact? Not necessarily. Critics point out that these readiness potentials might reflect preparation or bias toward a choice rather than the decision itself. The decision might still occur consciously even if earlier brain activity predisposes it. There's also the question of what free will means. If your decisions are caused by your brain state, but your brain state is you, then aren't you still choosing? The fact that neural activity precedes conscious awareness doesn't negate free will. It just shows that you includes more than just conscious awareness. Others argue free will requires the ability to have done otherwise. If the universe is deterministic, if all events are caused by prior events in an unbreakable chain going back to the Big Bang, then you couldn't have done otherwise. Your sense of choosing is an illusion. You're just playing out the predetermined consequences of initial conditions you had no control over. Quantum mechanics might offer an escape from determinism. If events at the quantum level are truly random, then the universe isn't fully deterministic. But randomness doesn't obviously help with free will. If your decisions are influenced by quantum randomness, they're still not under your control. They're just random. Some philosophers propose compatibilism. Free will is compatible with determinism. Free will doesn't require that you could have done otherwise. It just requires that you acted according to your desires and reasoning without external coercion. By this definition, you can have free will even in a deterministic universe. Others insist this isn't real free will, just a redefinition that sidesteps the hard problem. Real free will would require being the ultimate source of your decisions, which seems impossible if every aspect of your being, brain, thoughts, desires, is itself caused by prior factors you didn't control. And then there's the practical question. Does it matter? Believing in free will seems to have positive effects. People who believe they have free will are more ethical, more successful, and happier. Telling people free will is an illusion makes them more likely to cheat and less motivated to work hard. Perhaps the truth of free will matters less than the belief in it. Perhaps evolution equipped us with the illusion of free will because it's useful, regardless of whether it's real. Or perhaps the question itself is confused, based on misconceptions about causation, consciousness, and the self. Perhaps there's no fact of the matter about whether we have free will. The question is like asking whether a tree falling with no one around makes a sound. It depends on what you mean by sound or free will. We don't know. And this might be one mystery where we can't even be sure what we're asking.
Mathematics is a human creation. We invented numbers, geometry, algebra, calculus, all these tools for describing patterns and relationships. Yet this human invention turns out to describe the physical universe with stunning accuracy. Why does math work so well for physics? Newton discovered that planetary orbits follow mathematical laws. Einstein found that gravity is the curvature of space-time, described by differential geometry that mathematicians had invented decades earlier for purely abstract reasons. Quantum mechanics is built on complex Hilbert spaces and linear algebra. Again and again, mathematics developed purely for its own sake turns out to describe reality. As physicist Eugene Wigner put it, this is the unreasonable effectiveness of mathematics in the natural sciences. Consider imaginary numbers. Mathematicians invented the square root of -1, which doesn't correspond to any real quantity, purely to solve equations. It seemed like an abstract game. Yet imaginary numbers turned out to be essential for quantum mechanics. The wave function that describes quantum particles requires imaginary numbers. Without them, we couldn't describe reality. Or consider group theory, an abstract branch of mathematics about symmetry. It was developed in the 19th century to solve equations with no physical application in mind. Yet it became central to particle physics. The fundamental forces and particles can be elegantly described using group theory. The symmetries of nature map perfectly onto abstract mathematical structures. Why should this be? Why should the universe care about human mathematics? One answer is that math isn't really a human invention, it's a discovery. Mathematical truths exist independently, eternally, in some Platonic realm. Humans don't create math, we uncover pre-existing mathematical facts. The reason math describes physics is that physical reality is built on mathematical foundations. But this raises its own mysteries. Where is this Platonic realm? How do abstract mathematical objects exist? How do physical brains access eternal truths? The relationship between the abstract world of mathematics and the concrete world of physics remains its own puzzle. Another answer is that we've got it backward. Perhaps the universe is fundamentally mathematical. Perhaps physical reality is mathematics, not described by mathematics, but actually made of mathematics. This is physicist Max Tegmark's mathematical universe hypothesis. According to this view, the universe is literally a mathematical structure. Matter, energy, space, and time are not things that mathematics describes. They are mathematical objects. You, me, stars, atoms, all mathematical structures instantiated in some abstract space. This sounds bizarre, but consider everything we know about physics involves mathematical relationships. Mass, charge, spin, momentum, all defined by how they relate to other quantities according to mathematical laws. Strip away the mathematics, and there's nothing left. Perhaps there never was anything else. If the universe is mathematics, then the effectiveness of mathematics becomes tautological. Of course, math describes reality perfectly. Reality is math. But this pushes the mystery to a different place. Why this particular mathematical structure and not another? Why these laws of physics and not others? And how does mathematics, pure abstraction, give rise to consciousness, to the felt quality of experience? A third possibility is selection bias. Perhaps mathematics doesn't describe reality unusually well. We just notice and develop the mathematics that happens to match. We forget about the vast quantities of mathematics that have no physical application. Our impression of mathematics' effectiveness is distorted by only counting the hits and ignoring the misses. But even accounting for selection bias, the fit seems too good. Mathematics predicts new physical phenomena that are later discovered. It unifies apparently unrelated areas of physics. It guides research by suggesting what to look for. This seems more than just confirmation bias. The truth is, we don't know why mathematics works so well. We don't know if math is invented or discovered, if reality is mathematical or merely described by mathematics, if the effectiveness is real or illusory. The relationship between the abstract world of mathematics and the concrete world of physics remains one of the deepest mysteries.
Infinity is strange. Consider a hotel with infinite rooms, all occupied. A new guest arrives. Can you accommodate them? Yes, just move the guest in room 1 to room 2, the guest in room 2 to room 3, and so on. Every guest gets a room, and room 1 becomes free for the newcomer. Now, an infinite bus arrives with infinite passengers. Can you accommodate them all? Yes, move the guest in room 1 to room 2, room 2 to room 4, room 3 to room 6, and so on. all the odd-numbered rooms become free, infinitely many of them, for the bus passengers. This is Hilbert's Hotel, a thought experiment that reveals the strange properties of infinity. With infinite rooms, you can always add more guests, even infinitely many more. Infinity plus infinity equals infinity. Infinity plus 1 equals infinity. These operations that work straightforwardly with finite numbers break down once infinity enters. And there are different sizes of infinity. The natural numbers, 1, 2, 3, etc., form an infinite set. The real numbers, including all decimals, also form an infinite set. But the real numbers are a larger infinity than the natural numbers. This seems impossible. How can one infinity be larger than another? But mathematician George Cantor proved it. There are more real numbers than natural numbers, even though both sets are infinite. There's no way to pair up natural numbers with real numbers so that every real number gets matched. There will always be real numbers left over. In fact, there are infinitely many different sizes of infinity, each larger than the last. The hierarchy of infinities extends forever, infinite levels of infinity. These aren't just abstract curiosities. Physics deals with infinity in troubling ways. Calculating certain quantum interactions give infinite results, which can't be right since we don't measure infinite energies. Physicists use a technique called renormalization to subtract infinities and get finite answers. But no one is entirely comfortable with this. It feels like mathematical sleight of hand. General relativity predicts singularities, points of infinite density at the centers of black holes and at the Big Bang. Most physicists suspect these infinities indicate that the theory breaks down at extreme scales, but we don't know what replaces it. And then there's the question of whether physical infinity exists. Is the universe infinite in size? Are there infinitely many particles? Can quantities like density or curvature actually reach infinity, or do quantum effects or unknown physics prevent it? We don't know. Infinity is mathematically well-defined, but physically mysterious. Whether the universe contains actual infinities or merely very large finite quantities remains an open question.
In 1931, logician Kurt Gödel proved something shocking. Any mathematical system complex enough to include arithmetic must be either incomplete or inconsistent. Incomplete means there are true statements that can't be proved within the system. Inconsistent means the system contains contradictions. Since contradictions are unacceptable in mathematics, any consistent mathematical system must be incomplete. This was devastating to the program of reducing all mathematics to logic, of building mathematics on absolutely secure foundations. Gödel showed this couldn't be done. Mathematics will always contain truths that outrun our ability to prove them. The proof is clever. Gödel constructed a statement that essentially says, this statement cannot be proved. If the statement can be proved, then what it says is false, but we can only prove true things, so we'd have a contradiction. Therefore, the statement can't be proved. But if it can't be proved, then what it says is true. So there's a true statement that can't be proved. This has profound implications. It means mathematics isn't just a mechanical game of deriving theorems from axioms. There's an inexhaustible creative element. No matter how many axioms we add, new, unprovable truths will remain. Some philosophers have argued that Gödel's theorem shows that human mathematical intuition can't be replicated by computers. Computers can only follow algorithms, only mechanically derive consequences from axioms. But humans can recognize truths that aren't formally provable. Therefore, the human mind isn't algorithmic. There's something beyond computation happening in mathematical thought. Others dispute this interpretation. Perhaps human mathematicians are just sophisticated algorithms that we don't yet understand. Perhaps we only believe we can access truths beyond proof because we don't recognize our own limitations. Perhaps Gödel's theorem applies to human cognition as much as to formal systems.
Gödel himself seemed to believe in a Platonic realm of mathematical truth that minds could access intuitively, beyond formal proof. But this raises all the questions about Platonism we discussed earlier. The implications extend beyond mathematics. If mathematical truth can't be fully systematized, what about scientific truth? Physical theories are expressed mathematically. Does Gödel's theorem mean there will always be aspects of reality we can't capture in theories? Perhaps reality contains elements that are fundamentally resistant to complete theoretical description. Others are more optimistic, arguing that Gödel's theorem applies to formal systems, but not necessarily to physical theories. Physics is empirical. We test theories against observations. Perhaps empirical investigation can access truths that pure mathematics cannot. We don't know. The relationship between mathematical completeness and physical understanding remains murky.
Here's a specific mathematical question that's been definitively proven to be unsolvable. Not just unsolved, but provably impossible to solve using standard mathematical axioms. The continuum hypothesis asks, is there an infinity between the infinity of natural numbers and the infinity of real numbers? We know real numbers form a larger infinity than natural numbers. The question is whether there's an intermediate size, or whether real numbers are the very next level of infinity after natural numbers. This seems like it should have an answer. Either there is an intermediate infinity, or there isn't. But in 1963, Paul Cohen proved that the continuum hypothesis can neither be proved nor disproved from the standard axioms of mathematics, the Zermelo-Fraenkel axioms with the axiom of choice. This means you can consistently assume the continuum hypothesis is true or assume it's false, and either way, you get a valid mathematical system. It's independent of the axioms, undecidable. How can this be? How can a question about mathematical reality not have an answer? One view is that this shows mathematics is just a game we play with axioms. We can choose different axioms and get different mathematics. The continuum hypothesis doesn't have a real answer because there's no real mathematical reality, just different consistent systems we can construct. Another view is that our current axioms are incomplete. Perhaps there's a more fundamental axiom we haven't discovered yet that would decide the continuum hypothesis. Perhaps we need to think more deeply about what infinity really is. Gödel himself believed the continuum hypothesis was false, that there really is an intermediate infinity, and that we would eventually find the right axioms to prove it. But he never succeeded in doing so. This situation isn't unique. There are many statements that are independent of standard axioms. The deeper mathematicians probe, the more undecidable questions they find. What does this mean for mathematics? Is it built on bedrock or floating on axioms we arbitrarily chose? Are mathematical truths discovered or invented? Do numbers really exist, or are they just useful fictions? These questions merge into philosophy, and the boundaries between mathematics, philosophy, and even physics become blurred. We're left contemplating the nature of truth itself, wondering what it means for something to be true if proof is impossible.
Prime numbers are those divisible only by 1 and themselves. 2, 3, 5, 7, 11, 13, and so on. They're the atoms of arithmetic. Every other number can be built by multiplying primes together. Despite being completely deterministic, there's nothing random about which numbers are prime. Their distribution appears random. There's no formula that generates all primes, no pattern that predicts where the next prime will appear. Mathematicians have noticed statistical regularities. The prime number theorem describes roughly how many primes there are up to a given number, but individual primes seem to appear almost randomly. The Riemann hypothesis, one of the most famous unsolved problems in mathematics, connects prime distribution to something unexpected. the zeros of a complex function called the Riemann zeta function. If the hypothesis is true, it would explain patterns in prime distribution. But here's where it gets strange. The zeros of the Riemann zeta function seem to follow the same statistical patterns as energy levels in quantum systems. The spacing between these zeros matches the spacing between eigenvalues of certain random matrices, matrices whose entries are random numbers. Why should number theory connect to quantum mechanics? Why should the distribution of primes relate to random matrices? We don't know. Some physicists speculate that there might be a deep connection between number theory and physics. Perhaps prime numbers aren't just abstract mathematical objects, but reflect something fundamental about the structure of reality. Others suspect this is coincidence or an artifact of how we're looking at the problem. Perhaps the connection is superficial and we're being misled by pattern-matching instincts. But the mystery deepens. Other areas of mathematics show similar unexpected connections. Elliptic curves, geometric objects studied for their own sake, turn out to be essential for proving Fermat's last theorem and for modern cryptography. Topology, the study of abstract shapes, connects to quantum field theory. Number theory relates to string theory. Mathematics seems to be deeply interconnected in ways we don't understand. Areas that seem unrelated turn out to be secretly the same, different faces of some underlying unity. Mathematicians keep discovering bridges between distant mathematical territories, suggesting everything might be connected to everything else in some vast hidden structure. And then there's the question of whether mathematical patterns we observe are real or pareidolia, seeing faces in clouds. When we notice that prime distribution matches quantum energy levels, are we discovering a real connection or imposing patterns on noise? This question extends beyond mathematics. How do we know which patterns are real and which are illusions? The human mind is exquisitely good at finding patterns, sometimes too good. We see constellations in random stars, faces in toast, messages in coincidences. Science tries to distinguish real patterns from false ones through statistical testing and predictive power. But at the frontiers of mathematics and physics, where theories become increasingly abstract and observations increasingly indirect, the line blurs. Perhaps all patterns are human constructions, useful fictions we project onto an essentially patternless reality. Or perhaps patterns are real, and we're gradually uncovering the deep structure that underlies everything. We don't know.
Here's a strange question. Does mathematics require consciousness? Could a universe without conscious beings still have mathematical truths? On one hand, it seems obvious that mathematical truths are independent of minds. 2 + 2 = 4 before humans existed and will equal 4 after we're gone. The Pythagorean theorem was true for ancient Greek triangles and will be true for triangles drawn on alien worlds. But on the other hand, mathematics is an activity of minds. It's thoughts, symbols, proofs, concepts, all mental activities. Strip away consciousness, and what remains? Platonic forms floating in some abstract realm? But what does it mean for something to exist outside any mind? Some philosophers argue that mathematics is essentially linguistic. It's a language game played according to rules we invented. By this view, without language-using creatures, there's no mathematics. Just as without chess players, there's no such thing as a legal chess move. Others insist mathematics is discovered, not invented. Mathematical truths exist necessarily,
independent of whether anyone thinks them. Minds discover mathematics the way explorers discover continents. The continents existed before being discovered. But this raises puzzles about the relationship between abstract mathematical objects and physical brains. How do neurons, interacting chemically, access eternal truths about infinite sets? What's the causal connection between the physical and the abstract? Roger Penrose has argued that mathematical understanding can't be reduced to computation, that consciousness plays an essential role in mathematical intuition. He points to Gödel's theorem and the ability of mathematicians to recognize truths that can't be formally proved as evidence of non-computational consciousness. Most neuroscientists and philosophers disagree, seeing no reason why mathematical thinking can't be explained by computational processes, even if we don't yet understand the details. But the question remains: what is the relationship between mathematical truth and conscious minds? Are they independent or somehow necessarily connected? Could mathematics exist in a universe without consciousness? Or is consciousness required to bring mathematical truths into being? This connects to deeper questions about the nature of abstract objects generally. Do numbers exist? Do triangles? Do all the entities mathematicians work with, sets, functions, groups, spaces, really exist somewhere, somehow? If they do exist, how do physical beings like us know about them? If they don't exist, how can mathematics be true? These questions have puzzled philosophers for millennia, and we're no closer to answers.
What if reality is a simulation? Not a mystical illusion, but an actual computer simulation running on hardware in some higher reality. This idea, once pure science fiction, has been taken seriously by some philosophers and physicists. The argument goes like this: if civilization continues advancing, we'll eventually have enough computing power to run detailed simulations of conscious beings, ancestor simulations, recreating the past. If we run many such simulations, there will be far more simulated consciousnesses than real ones. If this is possible for us, it's probably possible for any advanced civilization. If there are many civilizations, they might run enormous numbers of simulations. The ratio of simulated minds to real minds across the universe could be billions or trillions to one. Therefore, it's more probable that you're a simulated mind than a real one. The odds favor simulation. Of course, this argument has holes. Maybe civilization always destroys itself before reaching simulation capability. Maybe running conscious simulations is impossible or unethical. Maybe we're wrong about consciousness being replicable on computers. But if the argument holds, we might be living in a simulation right now. This screen or page, your body, the entire universe might be rendered by some inconceivable computer. Could we tell? Maybe. Physicists have suggested looking for glitches, anomalies that might indicate the simulation cutting corners. Limits on computational precision might show up as fundamental constants like the speed of light or Planck length, minimum units beyond which the simulation doesn't bother calculating. The discrete nature of quantum mechanics, where things come in minimal units, might reflect the simulation's finite resolution, like pixels on a screen. Some propose experiments to detect simulation signatures, patterns in cosmic rays that might reveal underlying code, or attempts to use enormous computational resources that might slow down the simulation noticeably. But most physicists are skeptical. Even if we found such anomalies, we couldn't distinguish between this is a simulation and this is how physics works. Any pattern we discover just becomes part of our physics. And if we are in a simulation, what does that mean? We're still conscious. Our experiences are still real to us. The simulators might be as distant and incomprehensible to us as we are to characters in our video games. Does it even matter? Perhaps knowing we're simulated would be like learning we're brains in vats or living in the Matrix. Disturbing philosophically, but practically irrelevant. We'd still need to eat, sleep, work, love. The simulation would still be our reality. Unless, of course, the simulators decide to turn it off.
Science is our most successful method for understanding reality. But are there questions science cannot answer? Not just questions we haven't answered yet, but questions that are fundamentally beyond scientific inquiry. Consider values. Science can tell us what is, but not what ought to be. It can explain human moral intuitions as evolutionary adaptations, but it can't tell us whether those intuitions are correct. It can describe the consequences of actions, but not whether those consequences are good or bad. Some argue this gap is fundamental. Facts and values occupy different logical categories. You can't derive ought from is. No amount of factual knowledge determines what's right or wrong, beautiful or ugly, meaningful or meaningless. Others argue that values can be naturalized, explained in terms of human flourishing, which is a scientific question. Perhaps we can't derive absolute values, but we can ground ethics in facts about what promotes well-being. But this assumes well-being is the right foundation for ethics, which itself is a value judgment. The debate loops back on itself. Then there are questions about subjective experience. Science can study the neural correlates of consciousness, which brain states correspond to which experiences. But can it explain why brain states feel like anything at all? Can it bridge the explanatory gap between objective neural activity and subjective experience? We discussed earlier how this might be fundamentally impossible. The private nature of consciousness might put certain aspects of experience beyond objective scientific investigation. Purpose and meaning pose similar challenges. Science explains how things work, but not why they exist. It describes mechanisms, but not purposes. Not because purposes are hidden, but because science deliberately excludes teleology. Is there purpose to the universe? To life? To human existence? Science is silent, not because these are hard questions, but because they're not scientific questions. They ask about meaning, which science doesn't address. Some see this as a limitation of science. Others see it as proper scope. Science answers the questions it can answer and leaves other questions to philosophy, religion, or individual reflection. There's also the question of beginnings. Science explains events in terms of prior causes, but this creates an infinite regress. What caused the Big Bang? What caused that cause? Either the chain extends infinitely backward, or there's a first cause that's uncaused, and science can't address uncaused causes. Similarly, with laws of nature, science discovers physical laws, but it can't explain why these laws and not others. It can't answer why is there something rather than nothing, or why does the universe obey mathematical laws. These might be meaningless questions like asking what's north of the North Pole, or they might be profound mysteries beyond scientific investigation. We don't know.
Perhaps the deepest limitation isn't on science, but on human minds. Could there be aspects of reality that we're simply incapable of understanding? Consider how dogs perceive the world. Dogs are intelligent, but there are concepts they can never grasp. Calculus, quantum mechanics, philosophy. not because these are mysterious, but because dogs lack the cognitive architecture to represent these ideas. Now consider that humans evolved to survive on African savannas, not to understand quantum field theory or contemplate infinity. Our brains were shaped by natural selection to solve practical problems, finding food, avoiding predators, cooperating in groups. That we can do physics and mathematics at all is remarkable, possibly a side effect of general intelligence that evolved for other reasons. But why should brains evolved for survival be capable of understanding reality at its deepest levels? Perhaps there are aspects of reality that are to us what calculus is to a dog, not just unknown, but unknowable. Not because reality is hiding these aspects, but because we lack the mental capacity to grasp them. Philosopher Colin McGinn has argued for this cognitive closure, that human minds are closed to certain truths the way dogs' minds are closed to calculus. He suggests consciousness might be one such truth. The nature of consciousness might be perfectly explicable, just not to creatures with our cognitive architecture. This is a humbling thought. It means no matter how long we study, how clever our instruments, how sophisticated our theories, some aspects of reality will forever elude us, not due to practical limitations, but fundamental cognitive ones. How would we know if we'd hit such a limit? Perhaps mysteries that resist solution for centuries are hitting cognitive walls, or perhaps they're just hard, and future humans or AIs will solve them. We can't know, which is itself part of the problem. A cognitive limitation would be invisible from inside, like a program trying to understand its own source code when it lacks the concept to represent certain programming constructs. Some are optimistic that technology will transcend human limitations. Brain-computer interfaces might expand our cognitive capabilities. Artificial intelligence might understand what we cannot and explain it in terms we can grasp. Genetic engineering might give future humans new cognitive abilities. Others doubt that any augmentation would help. If reality contains aspects fundamentally beyond consciousness-bound thinking, then making consciousness smarter or faster doesn't solve the problem. And there's something melancholy about the idea. It means reality might be richer, stranger, more wonderful than we can imagine, not just than we do imagine, but than we can imagine. Like music to the deaf, colors to the blind, consciousness to the unconscious.
Donald Rumsfeld famously distinguished known knowns, known unknowns, and unknown unknowns. Known knowns are things we know we know. Known unknowns are things we know we don't know. Unknown unknowns are things we don't know we don't know. Gaps in our knowledge we're not aware of. Most of this script has focused on known unknowns, mysteries we recognize as mysteries. But what about unknown unknowns? History is full of examples. Before discovering radioactivity, no one knew to ask about it. Before germ theory, no one investigated microorganisms causing disease. Before recognizing DNA's role, no one asked how genetic information was encoded. These weren't just gaps in knowledge, they were gaps in conceptual space. The questions themselves were unavailable until certain discoveries made them thinkable. What unknown unknowns might exist today? What are we not even aware we're missing? Perhaps there are forces or particles we can't detect because we're not looking for them, not because they're subtle, but because we don't know what to look for. Perhaps there are phenomena that don't fit our categories of thought, like trying to explain color to someone who's never seen. Perhaps consciousness works in ways we can't conceive. Perhaps reality has aspects that don't fit into our dichotomies of physical versus mental, real versus imaginary, existent versus non-existent. Perhaps mathematics contains structures we can't represent, not because they're complex, but because they require cognitive categories we don't have. Perhaps the universe operates on principles that don't resemble anything in our experience. The frightening thing about unknown unknowns is their invisibility. We can't prepare for them, can't anticipate them, can't even discuss them coherently, because we don't know what they are. Yet history suggests they're always there. Every generation thinks it's close to complete understanding, only to have the next generation discover entire new realms of ignorance. The more we know, the more we discover we don't know. This is called the Socratic paradox. The wisest person is one who knows they know nothing. True wisdom lies in recognizing the vastness of our ignorance.
Is there a deepest question, a most fundamental mystery from which all others stem? Some say it's, why is there something rather than nothing? Why does existence exist? Why isn't there just pure void, no universe, no laws, no possibilities, nothing at all? This question seems to resist any answer. Any explanation would presuppose something, a cause, a mechanism, a principle. But if there's nothing to do the explaining. Perhaps nothing is unstable. Perhaps existence is necessary and nothingness impossible. But this sounds like word games. What does it mean for existence to be necessary? Necessary according to what? Some philosophers argue the question is meaningless. Nothing might not be a coherent concept. Even empty space is something. Perhaps there never was or could be absolute nothing. So asking why there's something is like asking why there isn't a round square. Others suggest the question has a theological answer. God exists necessarily and created everything else. But this just pushes the question back. Why does God exist rather than not? Another candidate for deepest question, why are the laws of nature what they are? Why this universe with these physical constants, these forces, these particles? We've touched on possible answers, multiverse, mathematical necessity, blind chance, or divine choice, but none feels fully satisfying. Or perhaps the deepest question is about consciousness. Why does anything feel like anything? Why isn't the universe just unconscious computation? Why is there experience? This question seems qualitatively different from others. We can imagine, at least in principle, answering questions about physics or mathematics, but explaining how matter becomes experience seems to require bridging a gap that might be unbridgeable. Or maybe the deepest question is about meaning. What is it all for? Not how does the universe work, but why? What's the point of existence, consciousness, life? Science doesn't address this question. It describes without prescribing purpose. Religion and philosophy offer answers, but they're diverse and contested. Perhaps there is no answer. Perhaps reality just is, without purpose or meaning, beyond what conscious beings create. Or perhaps we're asking the wrong questions entirely. Perhaps reality is stranger than these questions assume. Perhaps the deepest mystery is that we can ask questions at all, that the universe has become conscious enough to wonder about itself. That you exist, that you're conscious, that you can think and question and marvel. This might be the greatest mystery. Not something to solve, but something to experience and appreciate.
We've journeyed through countless mysteries: consciousness, the universe, life, mathematics, the limits of knowledge itself. It's overwhelming. How do we live with so much uncertainty? One response is anxiety. If we don't know what reality is, what consciousness is, whether we have free will, what happens after death, How can we make decisions? How can we live meaningfully? But there's another response. Peace. Acceptance that not knowing is the natural state. That certainty is rare and perhaps illusory. That mystery is not a problem to solve, but a reality to embrace. Consider the alternative. Imagine we knew everything. Every question answered, every mystery solved, every phenomenon explained. The universe completely mapped, no surprises left. Wouldn't that be boring? Wouldn't existence lose something essential? The wonder, the curiosity, the possibility of discovery? Mystery keeps reality alive. Each unknown is an invitation to explore, to imagine, to remain open. Not knowing means anything could be true. Reality could be far stranger and more wonderful than we suppose. And in practical terms, our ignorance rarely matters. You don't need to understand consciousness to be conscious. You don't need to know the origin of the universe to appreciate a sunset. You don't need free will to make choices that matter to you. The mysteries we've explored are intellectually fascinating, but emotionally they can be liberating. Not knowing frees us from the burden of having to be right, of defending our certainties, of being closed to new possibilities. It allows us to hold beliefs lightly, to say, this seems true based on current evidence, but I could be wrong. It fosters humility, openness, and curiosity, qualities that make life richer. There's also something deeply human about not knowing. The questions we've explored are ancient. Philosophers thousands of years ago asked the same questions we're asking now. Connecting with these questions connects us to all of humanity, past and future, united in wonder and ignorance.
How do we make peace with uncertainty? How do we live well despite not knowing? First, distinguish between different types of uncertainty. Some unknowns matter practically. Will it rain tomorrow? Should I change careers? These require decisions despite uncertainty, using judgment and probability. Other unknowns are intellectual. How did the universe begin? Do we have free will? These don't require decisions. We can appreciate them as mysteries without needing answers. Second, recognize that certainty is usually illusory anyway. Even our most confident knowledge might be wrong. Science has repeatedly overturned ideas that seemed certain. Staying humble about what we think we know is wise. Third, find comfort in probability. We don't need certainty, we just need good enough information to make reasonable choices. Most decisions can be made with incomplete information. Fourth, embrace curiosity. Not knowing is an opportunity to learn, explore, wonder. Instead of seeing ignorance as a gap to fill, see it as a space to investigate. Fifth, focus on what you can control. You can't know the ultimate nature of reality, but you can be kind to others. You can't solve the hard problem of consciousness, but you can appreciate your own experience. You can't prove you have free will, but you can make choices that align with your values. Sixth, find meaning in the process, not just the destination. Science isn't just about answers, it's about the joy of investigation. Philosophy isn't just about solutions, it's about the richness of thought. Life isn't just about achievements, it's about the experience of living. Finally, remember that mystery is universal. Everyone faces the same unknowns. No one, not the smartest scientist, most enlightened mystic, or most powerful person, has access to certainty about the deepest questions. We're all equally ignorant about what matters most. This is oddly democratizing. When it comes to the big questions, we're all beginners, all explorers, all equally clueless. The playing field is level.
Questions can be more valuable than answers. Good questions open up new ways of thinking. They reveal assumptions, highlight connections, deepen understanding. Why is there something rather than nothing might not have an answer, but asking it makes you contemplate existence itself, appreciate being, recognize how strange and miraculous reality is. What is consciousness might be unsolvable, but pursuing it has revealed connections between neuroscience, philosophy, quantum mechanics, and computation. The question has been generative, even without resolution. Where are all the aliens has no confirmed answer, but considering it makes us reflect on life's rarity, technology's dangers, our place in the cosmos. Questions are tools for thought. They direct attention, shape investigation, provoke insight. Sometimes the question is the point. The journey of asking matters more than any destination. This is especially true for the deepest mysteries. These questions might be fundamentally unanswerable, but that doesn't make them worthless. They're worth asking because asking changes us. We become deeper, more thoughtful, more aware of reality's strangeness. Children ask why incessantly. As adults, we often lose this habit, either thinking we know the answers or learning not to ask. But perhaps we should be more childlike. Keep asking why, keep wondering, keep marveling. Every answer raises new questions. Science progresses not by eliminating mystery, but by replacing crude mysteries with sophisticated ones. We trade "why does the sun rise" for "how does nuclear fusion work?", which leads to "what is the strong nuclear force?", which leads to "what is quantum chromodynamics?". Each answer deepens the mystery instead of resolving it. This might seem frustrating, but it's actually wonderful. It means reality has infinite depth. We'll never run out of questions, never exhaust what there is to know. The universe will always have more to teach us.
Does not knowing make life meaningless? If we can't be certain about reality, consciousness, purpose, or values, does anything matter? Existentialists like Camus argued that life's meaninglessness requires us to create our own meaning. If there's no inherent purpose, we're free to choose what matters. This is both terrifying and liberating. But perhaps the premise is wrong. Perhaps meaninglessness doesn't follow from uncertainty. Perhaps meaning isn't something we discover in the fabric of reality, but something that emerges from consciousness itself. Love matters. Beauty matters. Truth matters. Not because the universe says so, but because we experience them as mattering. The meaning is in the experience itself. You don't need to know the ultimate nature of consciousness to feel joy. You don't need certainty about free will to make meaningful choices. You don't need answers about the universe's origin to appreciate its beauty. Meaning might be relational rather than absolute. It exists in the connection between consciousness and reality, not as a property of either alone. A sunset isn't objectively meaningful, but your experience of it creates meaning. Love isn't written into physics, but it's real in the hearts that feel it. This suggests meaning is emergent. It arises from complex systems, brains, relationships, cultures, without being reducible to their components. Just as wetness emerges from water molecules that aren't themselves wet, meaning emerges from consciousness interacting with reality. And perhaps that's enough. Perhaps we don't need cosmic purpose. Perhaps the meaning we create, the values we hold, the connections we form, perhaps these are sufficient. After all, even if someone proved that God exists and revealed the universe's purpose, you'd still need to decide whether to care. You'd still need to find your own relationship to that purpose. Meaning requires participation, not just revelation. So maybe uncertainty about ultimate questions doesn't threaten meaning.
Maybe meaning is local, personal, created rather than discovered. And maybe that's not a deficiency, but a feature. It gives us freedom to shape our lives according to what we value.
Wonder is the beginning of wisdom, the ancient Greeks said. That sense of awe in the face of something vast and beautiful, that's where philosophy begins, where science begins, where art begins. Children have natural wonder. Everything is new and strange and marvelous. A butterfly, a rainstorm, their own hands. Everything prompts amazement. Adults often lose this. We become habituated. We think we understand things because we've labeled them. We see a tree and think tree without really seeing it. The intricate branching, the play of light on leaves, the way it grows and changes and lives. But wonder is a skill we can cultivate. We can practice seeing the strangeness in the familiar, the mystery in the mundane. Consider your hand. You've seen it thousands of times, but have you really looked? 5 fingers, each with 3 bones, covered in skin with unique fingerprints, moved by tendons connected to muscles in your forearm, all coordinated by neural signals from your brain. And that's just the mechanics. Never mind the mystery of how you can will your hand to move and it moves, or how touch sensations become conscious experiences. Your hand is a miracle. So is everything else if you look closely enough. The stars are nuclear furnaces billions of miles away, some already dead, the light just reaching us now. The ground beneath you is moving, carried by tectonic plates floating on molten rock. The air you breathe was exhaled by plants, which got their carbon from the air, which came from volcanoes, which came from the Earth's formation 4.5 billion years ago. Everything is connected in vast webs of causation, stretching back to the beginning of time. Everything is strange when you really think about it. Cultivating wonder means slowing down, paying attention, asking questions. It means treating the familiar as strange, the ordinary as extraordinary. It means staying curious. And it means appreciating not knowing. Wonder requires mystery. If we knew everything, there'd be nothing left to wonder about. Ignorance isn't an obstacle to wonder, it's the source of it. When you look at the night sky and contemplate how little we know, how we can't explain dark matter or dark energy, how we don't know if we're alone, how we can't even be sure what stars really are in their deepest nature, this can provoke either anxiety or wonder. Choose wonder. Let yourself feel small, but in a good way. Let yourself be amazed that you exist, that you're conscious, that you can think about these things. Let yourself marvel at reality's strangeness and richness and depth. This isn't just philosophical, it's practical. Studies show that experiencing awe improves well-being, increases pro-social behavior, and makes people feel more connected to others and to something larger than themselves. Wonder is good for you, and it's inexhaustible. The universe will never run out of things to inspire awe. The more you know, the more there is to wonder about. Knowledge and wonder aren't opposites. They're partners in an endless dance.
It's fitting to discuss mystery in the context of sleep, because sleep itself is mysterious. Every night, you lose consciousness. Your body paralyzes itself. Your brain produces strange narratives that seem real until you wake. You spend a third of your life in this altered state. Why? We still don't fully know. Sleep is essential. Deprive yourself and you'll die. But the exact functions remain debated. Memory consolidation, waste removal from the brain, emotional regulation, energy conservation. All these play roles, but the complete picture eludes us. And dreams remain even more mysterious. Why these particular images, these emotions, these bizarre narratives? Some meaning-making attempt by your brain? Random neural firing? Processing of emotions and memories? Gateway to the unconscious? All of the above? We don't know, and that's okay. You don't need to understand sleep to benefit from it. You don't need to decode dreams to let them refresh you. As you drift toward sleep now, let yourself appreciate the mystery. You're about to lose consciousness, to enter a state we don't fully understand, to experience things that may have no waking equivalent. Your brain will continue working, processing the day's experiences, consolidating memories, perhaps dreaming. Tomorrow, you'll wake. Consciousness will return, and you'll continue your life, all without fully understanding any of it. And that's the human condition. We're mysteries to ourselves, navigating a mysterious reality, using mysterious consciousness to explore and question and wonder. But we don't navigate alone. We're connected to billions of other mysterious consciousnesses, all trying to make sense of existence. We're connected to all life on Earth, sharing DNA and evolutionary history. We're connected to the cosmos, made of atoms forged in ancient stars. We're part of something vast and strange and beautiful. And we don't need to understand it completely to appreciate it, to live within it, to contribute to it.
This might be the most personal mystery. What happens to consciousness when the body dies? Does experience simply end, like a candle flame being extinguished? Or does something continue? Science can study what happens to the body: cellular death, decomposition, return of atoms to the environment. But what happens to the subjective experience, the sense of being someone? Science has no tools to investigate this. Near-death experiences provide tantalizing hints. People who've been clinically dead and revived sometimes report elaborate experiences: tunnels of light, encounters with deceased relatives, feelings of peace and transcendence, life reviews. These reports are surprisingly consistent across cultures. Skeptics explain these as brain activity during the dying process: oxygen deprivation, endorphin release, memory processing. The consistency might reflect universal features of how brains shut down. Believers argue the experiences are too vivid, too structured, too transformative to be mere hallucinations. Some report accurate observations of medical procedures while unconscious, suggesting consciousness might exist independently of brain activity. But these reports are controversial and contested. And even if they're accurate, they describe near death, not death itself. No one has died completely and returned to tell us what lies beyond. Philosophy offers various perspectives. Materialism says consciousness depends entirely on brain activity, so death ends experience permanently. There's no afterlife, no soul, no continuation, just nothing. Though nothing isn't even experienced since there's no one to experience it. Dualism proposes that mind and body are separate, so the mind might survive bodily death. But this raises questions about how a non-physical mind interacts with a physical brain, and what happens to this mind without a body.
Some Eastern philosophies propose reincarnation. Consciousness continues in new forms, though memories of past lives are usually lost. The sense of individual self might be illusory, with a deeper consciousness cycling through different incarnations. Others suggest consciousness merges back into some universal awareness, that individual identity was always a temporary pattern in a larger field of consciousness, like waves arising and dissolving back into the ocean. Religions provide elaborate afterlife scenarios, heaven and hell, reincarnation, resurrection. But these are articles of faith, not knowledge. They comfort believers and guide behavior, but they don't answer the question empirically. The truth is, we don't know. Death remains the ultimate mystery, the final frontier that no explorer has mapped and returned to describe. This uncertainty can provoke anxiety. Not knowing what happens after death can make death frightening. But it can also be liberating. If we don't know, then dogmatic certainty from any source should be questioned. We're free to hold whatever beliefs comfort us while remaining humble about their truth. And perhaps not knowing makes life more precious. If this might be all we have, then every moment matters, every connection, every experience, every breath, all infinitely valuable because possibly finite. Or perhaps continuity doesn't matter as much as we think. Even if death ends consciousness permanently, the ripples of our lives continue. The people we've touched, the ideas we've shared, the children we've raised, these persist. We live on through our effects on the world, through the differences we've made. And in the deepest sense, we're always connected to everything. The atoms in your body will disperse and become parts of other things, plants, animals, earth, air. You're already part of an endless cycle of matter and energy transforming through different forms. Death is just another transformation. This might not be the personal immortality many hope for, but it's a kind of continuity. You've always been part of the universe, and you always will be, just in different configurations.
We've explored countless mysteries, from consciousness to cosmology, from mathematics to mortality. Through it all runs a deeper question. What does any of this mean? Why does the universe exist? Why does it contain consciousness? Why are we here, able to ask these questions, able to wonder and explore and seek understanding? Some find meaning in religious answers. We're here because God created us for a purpose. The universe has meaning because it's the expression of divine will. Our task is to discover and fulfill that purpose. Others find meaning in human connection and contribution. We create meaning through relationships, through art and science and culture, through making the world better for those who come after us. Still others embrace absurdism. Life has no inherent meaning, which is both terrifying and freeing. We're free to create whatever meaning we choose, to live according to whatever values we adopt. Meaning is a human creation, not a cosmic given. Or perhaps meaning is in the experience itself. The universe has organized itself into patterns that can experience beauty, feel love, understand truth. Maybe that's enough. Maybe the fact of consciousness, of experience, of being, is itself the meaning. Consider how improbable your existence is. For you to be here now required an unbroken chain of causation stretching back 13.8 billion years. It required stars to form and die, seeding space with heavy elements. It required a planet in the habitable zone around a stable star. It required life to emerge and evolve for billions of years. It required your specific ancestors to survive and reproduce through countless generations. It required the particular sperm and egg that became you to unite at exactly the right moment. Change any of countless factors and you wouldn't exist. Yet here you are, conscious, aware, able to contemplate your own existence and the nature of reality. That's miraculous. Maybe meaning doesn't need to be grander than that. Maybe the fact that consciousness can arise from matter, that the universe can know itself through you, that you can experience and wonder and love, maybe that's sufficient meaning. And maybe the search for meaning is itself meaningful. Maybe we're not meant to find a final answer, but to keep exploring, keep questioning, keep seeking understanding. Maybe meaning is in the journey, not the destination. After all, if someone handed you a book with all the answers, the nature of consciousness, the origin of the universe, the meaning of life, would you even want to read it? Wouldn't it spoil the adventure? Wouldn't it take away the wonder? Perhaps mystery is essential to meaning. Perhaps not knowing is part of what makes life rich and interesting and worth living. Perhaps the questions are more important than the answers.
We've spent hours exploring what we don't know, contemplating mysteries that might never be solved. But there's one thing you know with absolute certainty. You exist right now. Whatever consciousness is, you're experiencing it. Whatever reality is, you're part of it. Whatever meaning is, you're creating it through the act of being alive and aware. This moment, right now, is the only thing you directly know. Not memories of the past, which might be false, not predictions of the future, which are uncertain, just this, the immediate experience of existing. Everything we've discussed, consciousness, the universe, life, mathematics, meaning, all of it comes down to this present moment of awareness. This is where everything happens. This is all we ever really have. The past is gone, existing only in memories and records. The future hasn't arrived, existing only in possibilities and predictions. But now is real. Now is where you live. Now is where experience happens. And now is mysterious too. What is this present moment? How long does it last? Why does it seem to move? We explored these questions earlier and found no certain answers. But you don't need answers to experience now. You don't need to understand time to live in the present. You don't need to solve the mystery of consciousness to be conscious. Right now, you're breathing. You're aware. You're alive. Whatever happens before or after, whatever the ultimate nature of reality, whatever the meaning of existence, this moment is real and immediate and undeniable. Perhaps this is the deepest wisdom, to be fully present, to appreciate each moment, to live within the mystery instead of trying to solve it. The great spiritual traditions often emphasize presence, being here now, accepting what is, finding peace in immediate experience. This isn't resignation or passivity. It's recognizing that life happens in moments, and this moment is the only one we have. Ironically, we've spent hours exploring what we don't know, and we end where we began, in the present, conscious and alive, experiencing reality directly. All the mysteries remain. We still don't know what consciousness is, why the universe exists, what happens after death, whether we have free will, what mathematics really is, or what any of it means. But we know this. Right now, you exist. You're experiencing something, and that experience, mysterious though it is real and immediate and undeniable.
As sleep approaches, let yourself release the questions. You don't need to solve the mysteries tonight. You don't need to understand consciousness or cosmology or the meaning of life. Let the questions drift away like clouds. They'll be there tomorrow if you want to return to them. But right now, you can simply be, simply exist. Simply experience this moment of consciousness before it dissolves into sleep. There's a peace in not knowing, a relief in admitting ignorance, a freedom in accepting mystery. You don't have to figure everything out. You don't have to have answers. You can just be here, now, aware and alive. The universe has been unfolding for 13.8 billion years. It will continue long after you're gone. Your consciousness is a brief flicker in cosmic time, here for a moment, then passing. But while you're here, you get to experience this incredible reality. You get to wonder and question and explore. That's enough. That's more than enough. That's everything. So let yourself rest. Let your breathing slow. Let your thoughts quiet. Let your body relax into sleep, that mysterious state where consciousness transforms into something else. You don't need to understand it. You can trust the process. Every night you've done this, released consciousness into sleep, and every morning it's returned. You know the pattern, even if you don't know the mechanism. Tomorrow you'll wake, and the world will still be mysterious. Questions will remain. Uncertainty will persist. But you'll continue living, experiencing, wondering. And that's the human condition. To live within mystery. To create meaning despite uncertainty. To find joy in the unknown.
Before sleep takes you, consider this. Aren't you grateful for mystery? Grateful that reality is richer than our understanding. Grateful that there's always more to learn, more to discover, more to wonder about. Grateful that the universe surprises us, confounds us, amazes us. If we knew everything, if all mysteries were solved, if every question had an answer, wouldn't that be a diminished universe? Wouldn't something essential be lost? Mystery keeps us curious. It keeps us humble. It keeps us open to new possibilities. It makes life an adventure rather than a solved equation. So be grateful for what you don't know. Be grateful for the hard problem of consciousness that makes your existence mysterious. Be grateful for the vastness of space that makes you feel small and connected. Be grateful for the origin of life remaining obscure, for free will being ambiguous, for mathematics being unreasonably effective, yet inexplicable. Be grateful for dreams you don't understand, for déjà vu you can't explain, for the strange experiences that remind you reality is weirder than you think. Be grateful for death remaining unknown, because it makes life precious. Be grateful for meaning being ambiguous because it lets you create your own. Be grateful for the present moment being mysterious because it's all you really have. And be grateful for consciousness itself, that you get to experience any of this, that you get to wonder and question and explore, that you get to be confused and amazed and awestruck. You are the universe looking at itself. You are matter become conscious, atoms arranged in such a way that they can contemplate atoms. You are a brief pattern in the cosmic dance, a temporary organization of energy that can experience beauty and seek truth. That's miraculous. That's wonderful. That's enough.
There's one more mystery we haven't discussed. What will you dream tonight? Dreams are nightly journeys into the unknown. Each sleep is an adventure into unpredictable territory. You don't know what you'll experience, where your mind will take you, what scenarios it will construct. Maybe you'll fly. Maybe you'll meet people you know, or strangers you've never seen. Maybe you'll be yourself or someone else. Maybe you'll experience impossible physics, strange emotions, bizarre narratives. Or maybe you won't remember any of it. Maybe you'll sleep dreamlessly, consciousness suspended for hours, and wake with no memory of where you've been. Either way, you're about to enter the unknown, to surrender control, to let your brain do whatever it does when you're not watching, to trust the process of sleep and dreaming and eventual waking. This is practice for bigger unknowns, practice for facing uncertainty, practice for letting go of control, practice for trusting that things will work out even when you don't understand how. Every night is a little death, consciousness ending, returning, transformed. Every morning is a little rebirth, awakening to a new day, continuing the adventure. And tonight is no different. You'll release consciousness into sleep. You'll trust that you'll wake. You'll accept not knowing what dreams may come. You'll surrender to mystery. And that's okay. That's natural. That's human.
So close your eyes if they're not already closed. Let your breathing deepen. Let your body become heavy. Let your thoughts slow and drift. You've journeyed through countless mysteries tonight. Consciousness and cosmos, life and mathematics, meaning and mortality. We've explored the boundaries of knowledge and the limits of understanding. We've contemplated all the things we don't know. And now it's time to embrace one more mystery, sleep itself. Let go, release, surrender to the unknown. The mysteries will be here tomorrow. The questions will wait. But right now, this moment, you can simply rest. You are conscious. You are alive. You are part of something vast and strange and beautiful. And that's everything you need to know. Good night. The universe remains mysterious, and so do you. Sleep well, wondering mind. Dream deep, conscious being. Tomorrow you'll wake, and the mysteries will still be there, waiting. But tonight, rest in the comfort of not knowing. Rest in the peace of uncertainty. Rest in the wonder of existence itself. Good night.
If you're still awake, that's okay too. Sometimes the mind resists sleep, preferring to continue wondering, questioning, thinking. Maybe all these mysteries have energized rather than relaxed you. Maybe your mind is now spinning with questions we've raised. Maybe you're lying awake, contemplating consciousness or cosmology or the meaning of it all. That's fine. That's wonderful, actually. It means you're engaged, curious, alive. But remember, you don't need to solve anything tonight. The mysteries aren't going anywhere. They've waited billions of years. They can wait until morning. And sometimes the best insights come when we stop trying, when we let questions sit in the background, percolating in our unconscious, when we trust that understanding will come in its own time. So if sleep isn't coming yet, just rest. Be comfortable with being awake. Be okay with not knowing. Be present with whatever thoughts and feelings arise. Maybe revisit your favorite mystery from tonight, not to solve it, but to appreciate it, to sit with the wonder of it, to let it inspire rather than frustrate. Or maybe just focus on your breathing, in and out. Simple, direct, immediate, real. You are here, you are now, you are conscious and alive and part of this mysterious universe. And that's enough. Eventually, sleep will come. It always does. And when it does, you'll dream your mysterious dreams and wake to a mysterious morning and continue your mysterious existence. Until then, rest, wonder, appreciate. The universe is vast and strange, and wonderful. And so are you. Good night, whenever it comes. May your dreams be interesting, your sleep be deep, and your waking be gentle. Everything we don't know is waiting, but it can wait. For now, just be.